Welcome back, everyone. It's been a bit since our last episode. Before we get to today's guest, big news. A lot has been happening behind the scenes. As some of you may have heard, Daniel and I, plus Eric Magro and Rebecca Ziegler from the Cryosphere Discord server mod team, have joined forces to put together the Global Cryonics Summit. This is an industry-wide gathering of cryonicists and those in the nearby orbit of cryonics to get together down in Miami, Florida on July 20th and 21st of this year. We're sponsored by all the big players, including the Biomedical Research and Longevity Society, BRLS, Alcor, Tomorrow Bio, Cryonics Rescue Canada, and CryoDAO. We're also doing this in collaboration with the Foresight Institute. In particular, BRLS and Alcor have been quite generous in helping us to make this happen. And these sponsorships have enabled us to throw a top-notch conference at a really great venue down in South Florida while keeping the ticket cost for attendees very low. We're focusing on three major themes: the growth and marketing of cryonics, the prospects for new and exciting developments in cryonics R&D, and the opportunities for new business models and organizations to support the industry. The schedule and speakers aren't finalized, but you can expect to see a lot of new faces from the cryonics arena that you may not be too familiar with. Groups such as the aforementioned CryoDAO and organizations like CryoPets, plus a lot of the more familiar faces from every corner of the industry under one roof for a full weekend, which is, we believe, going to signal a notable change in the growth and progress of the industry as a whole. So please go to globalcryonicssummit.com to get your tickets, or check the show notes to find that link as well. Again, we've managed to keep the ticket price very low, especially when you consider we're including breakfast and lunch over those 2 days. Whether you're working on cryonics officially in some capacity, or like us, Daniel and I included, not getting a paycheck from this industry and instead are members who really want to see this industry succeed for all our sakes. Whichever of those categories you find yourself in, this conference will be a great place for you to meet like-minded people, and yes, maybe even find some way to get more involved directly in a way that you find appropriate for your own situation. Daniel, did you want to add anything to that?
This has been percolating in the back of our mind for years now, and I'm pretty excited that it's finally coming together. I couldn't be more happy with the team, and this summit feels like a very natural next step to what's already been part of our extensive community building efforts. Traditionally, each of the individual organizations would tend to have their own separate gatherings, and while this is definitely important, it tends to be limited to just that organization's information. Amongst the goals that we're trying to accomplish here is not only facilitate getting everyone onto the same page, but to really bring to the forefront a lot of the untapped potential within the community. The one question we often get from both new and long-term chronicists is, how do we get involved? So if you are one of those people, this is one of those ways. There are many important and sometimes difficult conversations that need to be had, and we intend to have them. We are really aiming to be a unique event with a strong emphasis on being actionable. So we'll hope you will try your best to join us in Miami and participate. One other thing, I really want to reiterate our appreciation for the industry sponsors. The conference is only minimally funded through ticket sales. They are really making it possible for the average cryonics member to be a part of this conversation. And without their support, we would not be able to hold an event like this. I'm really excited. I hope to see everyone in Miami. Max, take it away.
Thanks, Daniel. And yeah, we can't say enough good about the sponsors that are really making this conference possible, without which we none of us would get this opportunity. So check the show notes. Again, that's globalcryonicssummit.com, July 20th to 21st in Miami, Florida. More info on things like hotel accommodations that we recommend and everything else are available on the site. And as new things get announced and become part of the conference, that will be posted onto that website as well. Okay, and now on to our guest. Today we're speaking with John Smart. John Smart is the co-founder of the Brain Preservation Foundation. He's a futurist. He's founded a number of other organizations that are involved in thinking about what the future is going to look like. If you've heard about things like aldehyde stabilized cryopreservation, Oregon cryonics, and other similar concepts, you'll have some inkling of what we will be discussing today on this episode. And now we bring you John Smart. All right. Welcome back, everyone, to the Cryonics Underground. It has been a short little while since our last episode, but today we are very lucky to be joined by John Smart, who is a futurist. He thinks of himself as a systems guy, but he has his fingers in so many different things that I wanted him to describe. John, how would you describe succinctly all the different things that you're involved with?
Oh boy. First I want to say it's an honor and a true blessing to be on with you guys, talking about the future of biostasis. Such an important topic for ourselves personally, for our families, for the world. And I really appreciate what you guys have been doing. I've been going back through a few of your previous pods, really enjoying your guests. And I guess I'm on because I'm vice president, co-founder of the Brain Preservation Foundation. But I got to BP, Brain Preservation, through my role as a futurist. So I guess I'd say primarily, I'm a single word, I'm a futurist. I'm also a foresighter. The field of thinking of the future breaks into two things. It breaks into the methods people use to look ahead and the stories people trade about the future. The first one's called foresight, like scenarios, trend extrapolation, causal models. The second one is called futures. And we use the term futures because the future is obviously diverse. It's a plurality of different kinds of futures that are possible. And different people who think about the future are attracted to different stories. But telling and critiquing our stories is really one of the big things that futurists love to do. And obviously in our field, the revival story is a huge futures piece, right? The whole question of what it'll be like for different people, all the different kinds of revivals that are possible, all the different stories that are currently being traded and the assumptions behind them. It's a really wonderful area. So I got into it through my study of accelerating change. So I guess you could say I was an accelerationist, one of the original accelerationists back in 2000. Started the first website in 1989 that looked at accelerating change from a universal perspective. It was called Singularity Watch. And basically, there's a subset of people who are really interested in what Carl Sagan called the cosmic calendar. Put all the interesting events on a calendar year, 13 months, or 12 months, 13 billion years, and you see this crazy acceleration of complexification the closer you get to the present day. And of course, life is an example of that. Human culture is an example of that. Technology is an example of that. And the question is, what is that? And so I started an organization in 2003 called the Acceleration Studies Foundation to try and understand this accelerating change. And what we kind of came to understand is that it's based on two things. It's based on kind of the craziness of the nano world, nanocosm, and also the unreasonable effectiveness of biology at adapting. Right, so biology and nanotechnology are kind of the two basic stories of accelerating change. The famous example for nano, Richard Feynman, Plenty of Room at the Bottom, 1960, when he argued what eventually people will be manipulating at incredibly small scales, and he was the first to basically explain the unreasonable efficiency of the small scale. So the example I like to give in my talks is, let's say you want to improve a chemical reaction. Well, you can come up with a catalyst that has a better active site in catalytic chemistry, and you can easily, with a small change a single amino acid residue, and you can get 1,000-fold, sometimes 10,000-fold, 4 orders of magnitude increase in either the speed of the reaction, the productiveness of the reaction or the efficiency of the reaction, speed, productivity, or efficiency. Single step innovation, 2, 3, 4 orders of magnitude increase. In fact, there are a few examples of millionfold magnitude increase in manipulation of things at the small scale in a single step. Working with something called a photonic crystal made these micro lasers that were 1 million times more energy efficient than all previous micro lasers. That's one person in one lab. You never do that at the human scale. At the human scale, someone invents something like flat pack furniture, Ingmar Kamprad, you get maybe 3x increase. Not even 1 order of magnitude, but just 300% more efficient packing furniture allows IKEA to emerge, right? So there's these two scales. And at the small scale, there's these incredible advances. And of course, the latest example of that is quantum computing. There's nothing more incredible that we can think of. It makes nanotechnology look tame, right? But there's something called Nevin's law, which is the speed at which computational effectiveness increases in quantum computing when you add one additional qubit. It makes Moore's law look like it's dead in the water, right? When we can create quantum computers that have many, many more qubits than they have today, we can imagine simulating at the molecular scale everything that's going on in biology. That's when the AGIs of the future, or even the AIs, they don't have to be general intelligence, will be able to do things like reorganizing our genome to create more immortality, create bioimmortality for us, or truly understanding how to make, say, post-biological life, right? How is that possible? This is all kind of crazy stuff that's possible only because of the small scale. So that was the big insight I got from the Acceleration Studies Foundation. And the other big one was that networks always win. Biological networks, because they both evolve and develop, are constantly accelerating. And the example I just give one good example in my talks, is the 6 great extinctions that have happened in human history, right? Life's history, right? The 5 that we talk about, and then the great oxygenation event, which everyone forgets, right? When bacteria learn to create oxygen, right? All of those extinctions, none of them, as far as we know, removed any significant amount of the network complexity, of the genetic complexity of those species. So you look one level down below the species, right, below the group, and look at the networks that were supporting the groups. And the networks actually increased the complexity of the forms and functions that emerged after every single one of those catastrophes. So that's, in biology, that's called hormesis. It's even more amazing than resilience, where you bounce back. It's where a stress makes you stronger. Nick Taleb had a book called Anti-Fragile, which talked about it in organizations. A stress that makes you stronger, that's how your bones and your brain and your immune system and all the important networks in your body work. You stress them and they get stronger. And the best example of this in human history is, the fall of the Roman Empire. 1,000 years of regression of large-scale organization in Western culture. What happened to the whole network? Well, those scrolls migrated to the Middle East, and because there was enough redundancy in the network, just like the genetic redundancy in the big extinctions, all the science and medicine and architecture flourished in the Middle East and in China independently, right, during that regression in Europe. So that, to me, is why acceleration always happens. And that model, I believe that those dynamics exist, and we're not yet smart enough to understand why kind of life and networks and intelligence at the network level is so adaptive. But as you can imagine, that feeds very much into my progress story, right? Sorry.
There's one thing I want to push back on a little bit, though.
Please.
It sounds like you're describing a system that, like you said, gets kind of attacked isn't quite the right word, but it suffers some sort of big stressor,
Yeah.
and then bounces back more
Learns.
strongly than before, and then suffers another stressor, and then
Yeah.
bounces back more strongly than before.
Yeah. Learns from it. Yeah.
But I don't know if the trilobites would agree, or the dinosaurs. They
No,
might disagree, right?
absolutely they wouldn't. Exactly. You have to.
They might
you
say
have
we
to,
were just a local maxima, then we
you
hit the
nailed
reset
it.
button and you found a new local maxima.
You nailed it. And then it's also possible you can have a stress that's beyond the design of the system, a planet-killing meteorite, and then the whole system disappears. So the stress of hormesis has to be within the design of the system, right? But you look at the history of stresses that have happened to our planet, and you see this curious, they call it a catalytic catastrophe, right? The catastrophe actually accelerates the complexity. The advanced tools and organizations of cultures emerged first in the north, where you had these periodic ice ages stress recovery, right? So there's this special thing that happens that seems to protect this acceleration, and it's something to do with biology. It's the way evolution and development work in networks. And yes, from the trilobites' perspective, catastrophe. Got to go one level down and see that the protecting network. I would argue it's the same thing is happening in my brain. I'm older than you guys, so I'm constantly forgetting things. But I will noodle around, remember some other aspect of the person, like where they grew up or something, and suddenly that memory, the name or the concept, will pop back. So my brain is using its network redundancy and resiliency to respond to the stress and reorganize and actually make that stronger as a result of the break. Just like I lift weights and I'm ripping muscles and I reorganize the resources, or if I'm taking a vaccine, I reorganize the resources in that system to make me more resilient to that kind of stress again in the future. That's such a weird thing. Now, we started off with a very weird kind of almost a digression, but this is how I got to this positive future story, right? Because one of the issues we have around looking to the future is it going to be a world where we want to come back, right? And we all have to make that choice. We have to decide. Is the world getting better? Am I able to help it get better? And how soon might I come back? That's another impact that comes from accelerating change. I'm one of the people who thinks there's really reasonable arguments that this revival thing is going to be happening, a century from now or less. It's not going to be happening 200, 300 longer years, because if you look at this rate of acceleration, we're seeing tremendous learning that's happening in the system. Yes, there's catastrophes happening everywhere, but the system does seem to be learning, and we seem to be getting better at minding the lessons, if that makes sense, of the catastrophes that are happening. I'm blowing a lot of positive smoke here. Right? You might say, okay, let's get real, right? And the reality is, progress studies doesn't even exist. Acceleration studies, which I wanted to happen, doesn't exist in academia. Progress studies, there's probably a couple places now, a couple universities. Tyler Cowen, famously, within the last decade, said we should have more of these. Right now, we're just trading stories. This is what's called futures. We're trading stories and trying to critique them. Daniel.
I don't think you're blowing smoke. I think a lot of people in the kind of the longevity and chronic space, I think the desire, the fact that they can see this brighter future is a feature that they have to be interested in this. I don't think you can. If you think it's all like doom and gloom, then you're just not going to be attracted to this way of thinking, because who cares about the future if it's going to be worse off. So I do actually think it's practically a requirement.
Well, I'm going to push back slightly on that. I think it's a requirement for most people, but there are the Ralph Merkels of the world, which you've had on, who say, no, this truly is an experiment. Just be in the experimental group, not the control group. And so he doesn't necessarily have as much, at least the way he describes it to me, as much faith that the future will be better. He just thinks that experiment needs to be done. He's in the what I would call the uncertain camp of the three. The reanimator, the uploader, the uncertain, which we'll talk about. And I think it's wonderful that we have people that are firmly in that camp, because we really don't know. It'd be arrogant to claim, right? We don't. Everything we just described is systems theory, by the way. It's not science yet. It's a subset of natural philosophy that hopes to become validated science, right? That we can actually say, yes, networks are constantly learning. Individuals are adaptive, yeah. Groups are adaptive, groups being the trilobites in that case. Individuals being the genes in that case. But networks, they're always the super adaptive. So individual societies and stuff, they can easily be, knocked in or out. Sorry.
There is one thing I want to clarify, which is I think it's a very safe assumption that the future is likely to be better than the present in many ways. Because this is a trend we've seen since the Enlightenment.
Yeah.
That things have been getting better, right? Human progress is a real thing.
For the network, absolutely.
Yeah, for humanity as a whole.
Yep.
And so I don't see a strong reason. One can say maybe that's finally going to change. Maybe it'll change next year. If we have a global nuclear war or something, right? But hopefully not. But But if the pattern continues, we can expect the future to be better. And I think Ralph would probably agree with that.
Yes.
That's likely.
Yep, I think he would. But when he talks, at least to me, about the justifications he's making, he says, well, I just want to be in the experimental group. I can't give you odds. It's kind of like when I did listen to you talking to Emil about, odds for things, and he didn't want to put odds on. And I think I really respect that perspective too. I'm a futurist, so I will go to some odds. I will say, I think one type of revival is more likely than another, but I'm also realizing it's just a bet. It's just a guesstimate I'm making. And it's not, different people are going to make different bets, and I really respect that. I respect it. I think that's where we're getting to now as a field, is we're realizing everyone's going to make different bets, and that's the beauty of a network. Right? A network is not a group with shared values. A network is an interdependent ecosystem of different individuals and different groups, all competing and cooperating together. That's so much more interesting than a group perspective or than an individual perspective. Okay, I'm biased now. I'm saying it's more adaptive. I shouldn't claim it's more interesting.
Oh, I know you're a fan of Scott Page as well,
yes.
as I am. So
cognitive diversity, exactly.
And his work on complex adaptive systems and everything, I think it's it's a great framework for understanding this kind of stuff.
We should mention his book, The Difference, came out in 2008, which is this idea that if you can measure cognitive diversity, which is not ethnic diversity, it's not even experience diversity, it's just different ways of thinking and being. If you can measure that and bring it into your families, into your schools, your societies, your organizations, you get these measurably better results on all the wicked problems, the hard problems that you can't solve, right? So you have to guess.
So let's see what the diversity of opinion is here, since you mentioned the odds. Without going into too much detail about justification about how you came to those odds, I guess what odds would you give for some form of revival from, let's say, traditional cryopreservation, some of the other methods, and maybe of the kind of more out there methods that you consider to be versions of preserving consciousness?
Oh, I would say pretty high for all of them. I even think straight freezing is going to be an inference that's possible. And of course, this is a guess right now. But I think the problem with saying that straight freezing a person, or even vitrification, where it doesn't look good under the electron microscopes, you can't convince your average neuroscientist today, right? Because the morphology's changed, it's shifted. All the receptors and all the molecules are still there, but it's been kind of shifted around. I think huge amounts of that information is still there and is going to come back. And I also believe personally, if I was given the choice of coming back 90% versus 0%, I would just jump on it. Even 70%, even 50%, I would jump on it. But that's because I believe living systems have this natural capacity to do what's called computational closure. So they create this model and they find homeostasis. The most fundamental thing about life is that it's homeostatic, right? In fact, it's one of the problems in neuroscience right now is knowing which parts of the brain are there just to keep the brain alive and homeostatic, and which parts are storing on top of all those homeostatic mechanisms all the things we care the most about, all the higher order things like memory, consciousness, personality. So homeostasis is so fundamental. We know that people who have lesions in their brain, they still believe they have kind of the whole picture. And so a person who recovers from a massive stroke, they still figure out a way to have that concept of full identity, right? They have that closed worldview, even though they've lost pieces. And the brain it has this capability of graceful degradation, where you can kind of knock out pieces of it. Of course, artificial neural networks do this too. You knock out pieces, but the system fails gracefully. It's not brittle. It just continually creates a subset. So I think I would be rebooted if I had only 50% of my current self, let's say, in terms of memory complexity and all of that. I'd be rebooted, and quickly I'd find a homeostasis, and I would just start growing from there again. So obviously a very positive story with a bunch of assumptions behind it, but I think those assumptions are all reasonable. The better we understand, biology and the brain, the better we're going to kind of be comfortable with this idea that, this system is continually improving and learning, and science and technology can already capture huge amounts of it and infer the other parts from what is often called the baseline brain, right? One of my mentors was Francis Crick at UCSD. I was very lucky to have him as a mentor, one of the co-discoverers of DNA. And he had this concept he developed with Christoph Koch called the neural correlates of consciousness. Where are the neural correlates? And then this idea of neural correlates of identity grew out of that, the NCCs and the NCIs. And the NCIs, the neural correlates of identity, are a small subset of all of the baseline components that you and I all share. The reason we can all we can all understand each other's words. All that stuff's going to be filled in by the AI of the future. What we really need to do is sprinkle on top of that the key neural correlates of our individual identity, and then that uniqueness that we all have will be preserved into the future. And I need to digress here and defend why that uniqueness matters. There's a book called The Guardian of All Things by Michael Malone, and the subtitle is The Epic Story of Human Memory. And this is a network-centric view of memory. That's why I love this book so much. He studied history. I think he's a technology scholar, journalist as well, and he studied kind of human history from the lens of every major advance in memory. What did it do for society? And so he looked first at oral tradition, my ability to pass on language to someone else, and then the ability to pass on written language, and then the ability to record various things, and then the ability to do computation on top of that. And in every single case where there was a significant advance in memory, culture radically complexified, and he would argue, and I would, improved. And so Ken and I, at Brain Preservation Foundation, he's the president and founder of it, right? And I'm a co-founder and vice president. We both think that kind of individual identity is that. It's going to have the same degree of benefit for future society as, the invention of language or books, right? It's going to have even more profound, because there's even more information, I think. Well, let's not speculate on that, it's going to be really significant, because as like Malone says, no intelligence is ever omniscient or omnipotent. So as far out to the future as we can see, the past will always be partly a mystery, and the future will be partly opaque as well, right? So every civilization wants to know itself better in the past, know its past better, so it can understand its present and future better. And so for me, that's a real huge justification for why this is so valuable for society, and why it's going to be, think of all the ways, I often use this term called the human experience-ome. We talk about the metabolome and all that. Imagine when you have all of these individual identities that are accessible to culture in the future. And it's going to be all these past ways of thinking, the diversity of that, and all of the existing ones at that time. And they're all part of this experience-ome. We're going to know so much more about ourselves, and like the bad ways of doing things and the better ways. But particularly when we understand the past, we get that big picture perspective. That's why the past is so helpful, right? Because it's more foundational, we can say. It's more first principles, right? To know where we came from. It's also computationally more tractable. That's another one of the reasons, this is a silly digression, but to me it's another one of the reasons why if the AIs ever wake up, they're going to look at us and say, oh my gosh, I really want to understand this system because that's where I came from. It's going to be so interested in that system and symbiotic with that system. Again, I'm being maybe a little too positive here, because there's going to be some negatives too, but it to me there's a reason why we preserve, if that makes sense.
You don't worry so much about AI alignment.
Well, I do.
You do, okay.
Yeah, because I have this concept I call the adaptation curve. Anything new that comes into a complex system can often make it less adaptive at first, so it's got to go through this adaptive valley before it gets to the other side. Think of first cities, first cell phones, first video games. Anything that comes in, it has this like dehumanizing, like texting while you're driving today. How many thousand people is that killing? Because the phones aren't smart enough to stop people from doing it. The phones are going to be smart enough to stop that eventually, and then you can get to a third generation where you get all the benefits of the new tech, but you don't get any of the. You get enough regulation of the downsides that it's obviously a net benefit, and you haven't gone backwards, right? Social media right now, bottom of the adaptive valley. We can see it'll eventually get to the other side, but everybody's been fleeing all the public ones to these private groups like Telegram and stuff because they're so toxic and so full of ads. You and I there's so little oversight over social media, you and I cannot buy our way into a Facebook that has no ads, even though we don't only have to spend probably $10 a month. Those bastards won't give us that ability. Excuse my French. It's so in the valley. But we know it will eventually get there, and we know that just like Google has, Google's brain is smart enough to fact check websites and punish ones that have 3 or more factual inaccuracies according to its rank brain, right? Eventually, we want that on all of our media. We want that ability to kind of sort out the deep fakes and the clickbait. But we roll through the valley at first, right? So.
Well, I think people's concerns about the valley for AI are, I guess, legitimate because it's such a powerful tool that,
yes.
That valley, even if we come out of it at the end, a lot of people we have to live through that valley. All the people right now, we have to live through that valley, and I think.
Yes.
I think
yes.
while I definitely kind of try my best to see past the valley, I think the short term could be very scary for those reasons.
I totally agree, and I think it's really wonderful that so many billions are being spent on AI alignment now. And this is going to sound a little bit, I'm not sure how it's going to sound. I don't think we're anywhere close to AGI. I think people are mistaking a clear view for a short distance. This is another problem in the future space. It's easy to see something so clearly and think it's coming tomorrow. but like the flying cars, right? There's so many things that have to happen before you get to that future. And so it's easy to, but I think it's great, even though I think it's going to be much later. I think it's going to be in the 2080s at the earliest. We're going to see the AGI, is the way I've written it. But there's a number of people, as we all know, in the accelerationist community who think it's coming, tomorrow, right? Could be here 10, 15 years from now. But even though I think it's so far off, it's fantastic. So much money, so many institutions, so many even people in the policy space are thinking about this, and because I think it is that important. And I have hopefully it'll be in the show notes. I have a 8-part series that I'm writing with a co-author who's just got his master's in computer science from USC, Nakul Gupta, and it's called Natural Alignment, and on Substack, Natural Alignment. And my model, Daniel, is that the way that's going to win going forward is going to be copying how life and its evolutionary and developmental networks work. That's how the AI is going to scale. I think it's going to run into complexity, unmanageable complexity limits. It's going to run into trustability. It's going to be like all the edge cases that are happening with self-driving cars today that are pushing them off much further because they don't have these biologically inspired models. They're actually working with something called dimensional reduction, which is a very simple thing that we do in the back of our cortex, but it doesn't include all the other things that we do. So I think you're going to need those features. Sorry.
Would biologically inspired models also include things like kind of merging with biology, Neuralink style things,
Yes.
cyborg type
Eventually,
type concepts?
I think so. Eventually, yeah. One of the really interesting things about the three camps of brain preservation, a reanimator, an uploader, and the uncertain, is that the uncertain camp includes the hybrids, right? The people who think, well, I don't really know how I'm going to come back, and it could easily be some hybrid, some version, some part of me. Everybody in the transhumanist community, not everybody, many people in the transhumanist community argue just how, all the post-biology people, they argue just how many benefits you get from post-biological systems you can't get in biological systems. And yet, we know these amazing benefits that biological systems have that may be very slow to come to post-biology. So it's quite possible, just like we have everybody, tens of thousands of people with cochlear implants, a few people with a retinal implant. Now we even have the artificial hippocampus for mice. Did you know that? You can actually put in a chip that functions like the hippocampus in a mouse, and it functionally replaces short-term memory in a mouse. It's unbelievable. So that's a hybrid. Where could that fusion go in the future, where you have this part of you that's technological, part of you that's biological? You might not even carry the biology in the tech. It could be wirelessly connected to you. And this gets, sorry.
I was going to say, John, I wanted to make I think you said a very important point, and I wanted to highlight it, which was that the way to solve the alignment problem may be by thinking of these systems in a more biological way, in a more complex adaptive systems approach.
Yes.
Because I think I'm in the minority here. Maybe we both are if we're aligned on this issue, but most people, I think, believe that the way to deal with this problem is by having just a handful of big players in the space, and then controlling and monitoring them and directing them very specifically in how they operate and how they function and how they progress.
Yes.
Which to me sounds like the opposite of what you want to do, because they're not going to learn that way. They're not going to, you can't have this ecosystem that's able to learn things like learn tit for tat, right? Learn how to deal with the prisoner's dilemma.
Well said.
You can't do that if you have a handful of giant players. You need a lot of small players.
Yes. I can, to be fair and as empathic as possible to them, I can see the argument for that in an early stage when it is kind of easy to do that, and when the systems are, when maybe getting people all aligned around a set of regulations is going to be helpful in the very beginning, but at some point the technology commodifies and it gets cheap enough that anyone can use it. And that's why I have a huge faith in the future of open source, because it totally dwarfs all the coding done by any of the powerful actors today. And so, just look at when Llama escaped, right? That LLM escaped from, like, it was Stanford, into the open source community, and then suddenly open source had all the best leaderboards on what these things could do, and now all the big powerful actors had to watch those open source leaderboards to see which LLM was doing better for what type of thing. And then, that's where they recruit their AI talent, and that's where they learn, because the ecosystem always wins, the network always wins. But there is a point to this top-down control. You need a certain amount of it, and then at a certain point, the bottom-up emerges. But I think it's, we've all heard the term mobocracy versus democracy, right? It's quite easy to get these kind of chaotic effects happening in a system that is too anarchic and doesn't have enough top-down control. Again, I go back to biology. You and I have genes in ourselves that are developmental. They do all this top-down control. They kind of like the framework of the painting, right? They keep that system working so that my kid looks similar to me in all the developmental ways. But in all the evolutionary ways, that kid's different from me. So there is, and mostly it's bottom-up. Mostly biology is a bottom-up system. Back to your point of that, you really want the ecosystem. You want the competition. And yet you have to have a certain number of these top-down rules. The faith that I make is that that's actually, that model is going to beat out. If you think of all these people who are doing rational design of the next generation of frontier model or LLM, that's a top-down engineered type perspective. What's going to happen, and this is what I say in my series, what's going to happen when somebody develops a hardware description language that unfolds a neural net, and the hardware description language is like genes. It unfolds a neural net, which is the organism, and then you have piles of these, and then they're in a selection environment, in a community, interacting with each other. Maybe they're doing generative adversarial stuff, or they're doing cooperation stuff, tit for tat stuff, right? Positive stuff. And we're all watching that. In that selection environment, we are selecting the ones that are more trustable based on audited past safe behavior. And then, like I say, domestic animals, right? We didn't design any of their brains, and yet we know they're highly trustable, because we've had 10, 20,000 selection cycles on these dogs and cats and cows and horses. And that, to me, is, I think, my bet is that approach is going to win. And if it does, then the future of security for AI is going to be natural alignment in the same way humans. It's the exact same problem of human security. Right? Because humans, we are statistically trustable, right? We're, as Peter Turchin says in Ultra Society, 20,000 years of war have made us super cooperators. It's that paradox that we select for this pro-sociality. The catastrophe actually makes the pro-sociality stronger, right? And so there's something about the way the network learns which we have to wave our hands today when we talk about it. We don't really understand it, but I say network science is going to be the future of complexity science. We're going to start to see how, under the right conditions, these networks just get so much more trustable, and the network of humans is pretty darn trustable if you believe, Rutger Bregman and Humankind and Steven Pinker, Better Angels of Our Nature. You look over, a few hundred years, and you see this incredible decrease in the degree and severity of violence, even though individual cases can be much higher. To me, that's the solution you have to have in a world 100 years from now, when any kid can make, a nuclear bomb in their basement with some advanced AI, let's say, right? The solution is a network, a global kind of immune system that's humans and machines all working together, that understands, that has enough transparency, just like your own immune system does, that the few kids that are going off into becoming bad actors, well, they get a little extra help and they get a little extra transparency on them, so that they can be guided back, right? And in that's the kind of statistical security that I think you're going to have. The example I like to give is, planes and cars are weaponizable today, drones, but drones already have geocaching in them, so they can't fly over airports and stuff. What's going to be the future of any hardware that anyone uses that's smart enough to not be misused? Well, that's a very desirable future, I would argue, right? But how does it get that smart? Well, it has to learn the network ethics. What is allowable, what isn't. How do you learn that stuff? Through trial and error and selection, right? And that to me is kind of the critical thing that has to happen. Now,
well, it sounds like we're on the same page on a lot of these things. I think the opposite of these views is some sort of monopolistic regulatory capture framework for AI development, and I think that would be very dangerous. So hopefully,
and I think it's important to mention that we already see that playing out with China versus the United States, right? We see a weak version of that, where they're building the social credit score and kind of the top-down Orwellian state. They're using these advanced tools to kind of keep the system into what we call a pyramidal structure, versus the West is much more of a flat, amorphous network, right? More scale-free, not fully, but more that way. And ideally, it's something in between, fully bottom-up and fully top-down. It's something that kind of gets the benefit of both. Representative democracy, that's our term we use, right? Which includes both the top-down and the bottom-up. And how do you figure out where the right level of representation is? Well, I think the West is winning. I think we already see that now. We're so early into the age of AI, but we're already seeing nobody's buying the Huawei stuff. Everybody's backed off and said, no, I need to be able to trust, if I'm using this advanced technology, that it's open, that it's democratic. And I don't want to say anything that too critical of the Chinese. The Chinese people and the Chinese entrepreneurs are so hardworking, and they're building so many wonderful things globally. And the Chinese entrepreneurs globally, like BYD, they're not the Chinese government. So I recommend investing. I invested in BYD. I have probably almost 10% of my stocks are in some of these leading Chinese companies. Now, the rest of them are in Western democracies, but still, I think the Chinese entrepreneurs are a lever that's going to help fix this top-down, dangerous kind of model that we're seeing emerge in AI in leading autocracies, primarily in China, and being exported to a few of their client states at the moment.
Well, hopefully China stays away the CCP stays away from Taiwan. So otherwise, your stocks may take a tumble there.
It's a really good question, isn't it? And BYD actually is not dependent upon that. That's one of the reasons why they're the leading EV manufacturer now. They just passed who was it, Tesla, right? As last year. So yes, that's right. TMC, excuse me, and a few of these other wonderful, amazing Chinese companies, right? It's a huge unknown for us. Are Americans, and as the West, but America in particular, are we going to come to their aid? We had Nike missiles, nuclear-armed Nike missiles on that island in the 50s. Everyone forgets that. Taiwan exists because America protected it. And now we're backing off, slowly backing off from that. Yes. So can everybody agree that that Taiwan will eventually become part of Taiwan if they want it? I mean, can we work out some system? No, the UN's not smart enough or powerful enough to do that. So everything is still in the stage of, well, are we gonna let them fall, or are we gonna actually come to their aid? Huge unknown. And like you say, Taiwan has done so much for the world. So I hope they continue to survive going forward.
Hopefully go ahead, Daniel.
Well, I was going to try to topic discussions of futurism have the unique capability to go off
Going forever.
Go forever and go off on 100 different tangents. So
thank you, Daniel, for bringing us back. Thank you, sir. Thank you.
I'm hoping we can bring it back to brain preservation and maybe discuss a little bit about the Brain Preservation Foundation.
Wonderful. So BPF is an organization that wants to help validate or invalidate preservation science, right, in all of its forms. And fortunately, I can say validate is pretty much what we're doing now. There's very few things that seem to make it look like it's not going to be. It's going to be a non-starter. When we started in 2010, we weren't so sure, but I actually learned about something called chemopreservation, right? Which is you can take tiny pieces of neural tissue and you can fix it with glutaraldehyde, and then you can resin embed it and dehydrate it, and then you can put it under an electron microscope, and it looks perfectly preserved. It looks just like normal tissue, and that's kind of amazing. And so a question I had is, well, could that be scaled up for whole brains? Because that to me was a really interesting, elegant way to lower the cost, because these chemicals are cheap, and to also make it simpler, so that I could just turn my brain into this perfect plastic fossil, right, or resin fossil, and then I don't necessarily have to depend upon an organization to keep me up. I could give my brain to I could put it in contract storage. I could give it to a services company. I could give it to my kids, and I'm there. I'm still there. What a crazy idea that is. And then what I realized is that the least behavior change for people could involve a few forward-looking cemeteries setting up mausoleums with these plastinated brains. And every time I went to a mausoleum as a kid, I thought, wow, that's so interesting. We do this to honor people, but there's like nothing there except the name. Wouldn't it be amazing if you go to a mausoleum, a beautiful location, and then, and your grandmother's in there, and now, you actually think Granny's coming back, and you're going to go in there too, right? What an interesting world. It's the least behavior change for people, and it would involve a small amount. It would involve something that would be a fraction of the cost of a casket burial, right, to do this preservation procedure, assuming we have to take standby out of it, which we haven't discussed, right? But wouldn't that be interesting? And so I searched chemopreservation.org, and that's when I found that Ken had reserved this already. And Ken was thinking about starting a website like that. And he was doing brain preservation, scanning and uploading of neural tissue. He invented something called ATLUM, which is a technique for preserving and then slicing nanometer thin layers of brain tissue and then uploading them into the computer. And there's another technique called FibSem, which uses focused ion beams, and it actually kind of sands away the surface of the brain, and it uploads everything as it's watching it. And that's a destructive technique. His technique is a non-destructive technique. And it turns out there's several other techniques besides that, and they're all making a lot of progress, right? And they're uploading brain. At the time that I contacted him, they were uploading zebrafish brains with the size of like 80,000 neurons, the size of the tip of a pencil lead. Just scanning them and uploading them, all computerized. And I looked at that. That's incredible. That's incredible. Look at the momentum of this process, right? This is going to keep going. And so we realized that it was high time to really kind of put brain preservation under the electron microscope. That was his kind of subheader, right? And try and understand it, right? Is it going to work? And so we had these two missions, right? The scientific mission of assessing the efficacy and potential affordability of these procedures for people, right? And then the social mission is kind of understanding the value of keeping a healthy brain our entire lives. That's the obvious one. And then the second one is, if we can demonstrate efficacy of these techniques, we want to advocate for patient rights and accessibility. We want to actually start legally doing some legal challenges to make sure this stuff becomes more available. We're probably going to talk later about some of the cool legal challenges people have done that have really increased accessibility around some of these options, right? And so we reached out to some philanthropists. We were very lucky to get one to give us $100,000 for a prize for small mammal and large mammal brain preservation. And then in 2016, the small mammal prize was won with a rabbit, and then 2018, the large mammal prize was won with a pig's brain. And they were both won by a group called 21st Century Medicine. Robert McIntyre and Greg Fahey. Greg Fahey's a longtime cryonicist, right? A chronics researcher. They won it with a technique called Aldehyde Stabilized Cryopreservation, or ASC, which you guys have discussed before, so I don't need to go into it. It's basically a technique where you fix everything first with the aldehydes, cross-link it all, and then you put it in cold, right, in extreme liquid nitrogen cold. And there was another competitor. This is a bit of a tragedy. It was Sean Mikula at the Max Planck Institute in Germany, and he went for chemopreservation, that original idea that kind of got me excited, this resin embedding of the brain, right? Fixation and then resin embedding and then fixing the fats. But unfortunately, he didn't do perfusion, he did diffusion. So the glutaraldehyde, unless you get it right, didn't go all through the whole brain. So parts of the inside of the mouse brain were not perfectly preserved. They were preserved, but not perfectly. And the brain cracked. That's the most important problem, is it was cracking as he was curing the resin. And in my opinion, that's irrelevant. I'd be happy to have my brain cracked because I think I know enough about how the neuroscience works that the AI is just going to stitch that all together. But we didn't have anywhere in the prizes that was allowed because we don't know for sure. No one has done that careful research to say, oh yeah, this jigsaw puzzle, I can fix all those, right? The morphology's still there. And then unfortunately, he didn't do perfusion of the mouse, which is harder to do. And what's happened since, I think 2018, no, it was probably 2020, a technique called switch was invented. This is this incredible technique. Glutaraldehyde and formaldehyde are these beautiful cross-linkers, right? I should just basically do the digression into how they work. So formaldehyde has a single aldehyde in it, and that aldehyde, and it's a small molecule, so it diffuses very fast, but it weakly links things. Then there's this thing called glutaraldehyde, and it will diffuse slower, but it has two aldehydes in it, and it very well cross-links everything into this cage where nothing can move. And you can diffuse, this technique was invented at MIT by Kwang Chung, I think 2-3 years ago, switch. SWITCH. You can look it up. Kwang Chung, MIT. And the switch protocol diffuses the formaldehyde first into any brain of any size through the vasculature, because you probably know you're within millimeters of every brain, every neuron. There is a capillary system, right? It's got to supply oxygen everywhere. So you put this chemical in, and it just diffuses everywhere from the vasculature into the neural tissue. And then after the formaldehyde is weakly linked, it quickly stopping everything from changing. That's not a long-term solution. We have brains from 200 years old that look a little bit, they've lost some of their definition. They've lost some of they've lost their membrane integrity, right? So we can't prove yet with today's neuroscience that Broca and all of his 200 brains that Carl Broca did, 200 and some odd years ago, we can't prove that he's still there and that he'll pop out, right, in the future, because the membrane integrity's gone, because they use formaldehyde and not glutaraldehyde, and they didn't store it at refrigerator temperature. At refrigerator temperature, as far as the research that I've seen so far, says nothing changes. Once you have glutaraldehyde in refrigeration, you're good, right? For people we don't really know when, and the accelerated aging experiments are still very early, but hundreds of years glutaraldehyde liquid, or what Andy McKenzie at Oregon Brain Preservation calls fluid storage, right? It seems very likely that that's plenty good enough, right?
Can you describe what you mean by cross-linking?
Yeah, so cross-linking is the ability to take a protein and link it to an aldehyde and then link the other aldehyde group to another protein. So basically, your cells are just chock full of all these little protein machines, right? And the cytoskeleton that helps route things around inside and keeps the cellular system homeostatic and able to run all of the informational systems, right? All of the gene protein regulatory networks that underlie all the circuitry that is essential to how our brain works, right? And we have three kinds of memory. We have short-term memory, which is actually the active loops of action potentials. Gerald Edelman called them the thalamocortical loop. He thought was the most important one to understanding how consciousness, a subset of these dynamic circuits, works, right? It was his model of consciousness. And so we have to actually repeat a number in our head or it will fall out of working memory, right? Sometimes, right? If it's more than 7 digits or whatever, right? We can't chunk it. So that's short term, and then, that's working memory, and that's the actual action potential. That's the dynamic process. And then we have short term memory, which is anything that we've learned over the last 2 days, and that is stored in the brain with a series of pointers, as I understand it, in the hippocampus from the last 2 days, and it's not stored permanently. It hasn't been stitched in to the actual protein structure of the brain, but it's much more storage is capable in these in short-term memory than in long-term memory of the recent experiences we've had. That's why if you cram like crazy for a test and you walk in very carefully, you don't want to shake your head too much or it'll fall out, and you sit down, you can kind of regurgitate it all on that test and just do this incredible performance, right? But that's just the last 48 hours, and that gets wiped to make room for the new stuff happening that's all hippocampally mediated, right? For the next day's worth of experience. And then sometime, one of the current models is it's during slow wave sleep. It's when you have no REM. You're actually consolidating pieces of that short-term memory into the long-term memory, and you're stitching all those babies down into the actual protein structure of the brain. Those 100 or 80 billion neurons with an average of 1,000 synaptic connections to other neurons, right? 80 trillion unique synaptic connections. That's so amazing. That is worth protecting, I would argue, right? That is so complex. It's been described as the most complex developed structure in the known universe, right? The only thing more amazing to me than the brain is the evolutionary developmental system network that unfolds a brain, right? A thing you cannot even see, a fertilized egg turning into you. That's the most incredible thing that I've ever thought of, right? That's why, to me, understanding that system, figuring out how to import a crude version of that into the AIs, that's going to beat all the other systems, in my opinion, because it's going to come up with its own solutions, and you and I are just going to be gardening it, selecting the ones, I call it the Labrador dogs, right? We're going to be selecting all the ones that are symbiotic with us, and then the raptors, we'll keep a few of those around in cages. The military will release those occasionally, but there'll be way more Labradors than those guys, so that we can overwhelm the bad actors. And then whoever's doing some crazy thing in their basement, the rogue AI people, they're going to be overwhelmed by the ones that are trainable. That's how the immune system works, right? Your immune system is so incredible that it has built trained T cells for every kind of antigen that any bacteria or virus could ever throw at you. Not just the ones that it's seen in the past, but it has actually computationally modeled every possible type. And it has an average of 10 T cells trained sitting in the network waiting for that type to possibly attack you. That is such an incredible level of security, right? Now, I would argue that's the level of security, that network security, that we will have to go to with, back to the natural alignment with an AI system that we feel, hey, yeah, that's truly, that's as safe as nature, right? That would be where I think we have to go. And now I've completely lost the thread. What were we talking about?
Well, yeah, I mean, it sounds to me like a lot of your interest in the Brain Preservation Foundation is really around preserving that memory soup and all the different, as you described, all the different ways of doing that.
Yeah.
All the different ways that have been successful or partially successful.
I would argue it's only that because to me that, and Ken feels this way, I learned this from Ken, is that the memory is the tractable one right now. We can't really get an agreement on what consciousness is, but we can get a lot of agreement on the so-called synaptic theory of memory, and then the specific ion channels and proteins that are necessary for that. Oh yeah, glutaraldehyde. So glutaraldehyde ties all that stuff up beautifully and puts it in something, it's a gel, right? It's not really a solid or a liquid, right? It's a gel, and it's sitting there and it's not going to move. And the switch protocol figured out, Ken recently taught this to me. They learned that you can put in, these guys at MIT, Kwang Chung and his team figured out that you can put in the glutaraldehyde in an acidic environment. You make the brain acidic, right? Low pH. And that glutaraldehyde will not cross-link until you increase the pH. Because the big problem with glutaraldehyde in the early days of chemical fixation was you'd put it in and then it would start cross-linking. It would create a barrier for the glutaraldehyde to go through the rest of the brain. And now the chemists have figured out, no, the formaldehyde's going to go everywhere. It just naturally does that because it's a weak linker. The glutaraldehyde goes in low pH. It goes everywhere. Then you increase the pH. You turn the whole brain into a gel. And then you do interesting things with that. Lots of interesting things. And that is what the entire kind of digital pathology community is doing right now. The entire field of pathology is being revolutionized, tissue processing, by these new fixation techniques. And that's why fixation is has so much momentum right now. If we can fix tissue and understand it better, medical science improves so much. So just in the last 5 years, all of these really fascinating new tools for fixing and then imaging and uploading have emerged. There's something called laser. I'm forgetting the name. It's planar microscopy, and it involves a laser perpendicular to the optics, laser fluorescence microscopy, laser fluorescence sheet microscopy. And what happens is the laser, you put in these, you fix the tissue, and you fix it in a way that allows you to get these antibody probes throughout the entire neural tissue, and then you shine the laser as a sheet, and the fluorescent, the chemicals that or the fluorescent probes that have attached to specific molecular features now fluoresce, and then you upload all that data plane by plane into the computer, and now you have this amazing big scanned image of a brain that now includes features that you didn't have before, because you couldn't get the specific location of all these specific molecules, that some subset of those are key to memory, identity, personality. And this is the big insight that I think is going to come in the field of learning and memory, is we're going to start understanding what aspects of those really are the most important to protect, and then our preservation protocols, both the vitrification and the fixation protocols, are going to be greatly improved in their validation from that those kinds of.
So I just wanted to in terms of clarification and classification, I'm glad you said fixation. Is that the appropriate word that kind of sums up all the different methods in this camp of things? Because I hear people somewhat, I would say confused, but people use different terms. And so if we were to say vitrification as part of cryopreservation, and then we should say fixation for all these other types of methods.
Yeah, as I understand it, it is. I would say that there's these 6 methods now that we should all be thinking about. There's 3 cryogenic methods and 3 non-cryogenic methods. And the cryogenic, we all know, the straight freezing, vitrification, and ASC. The non-cryogenic now are this fluid preservation, that glutaraldehyde that I mentioned, and then liquid storage, right? This gel. And then there's this tissue clearing method. The one I just described to you is a tissue clearing method. Clarity was the first one that emerged. There's a bunch of others. Shield is another one, again, out of the same MIT group. And what these do is they fix with glutaraldehyde, and then they remove the fats. They use detergents, and they actually wash the fats out of this fixed brain. So all the protein, remember I was saying how all the memories are stored, the long-term potentiation is stored in these synaptic weights and the receptor densities and some other critical molecules. And people don't know what the modulation molecules are, whether the phosphorylation states of certain proteins modulate this. This is still a emerging area of understanding. But the glutaraldehyde preserves all that stuff. And if you want to wash the fats out with these soaps, that's tissue clearing, or it's also called expansion microscopy. And when you do that, you can make the brain transparent. And that's where you can use these tools that I just mentioned, and you can probe where all these various molecules are and the states of the molecules. And that's just this huge new area of neuroscience and pathology that is really, roll that forward 10 years and we're going to know so much more about how the brain works at the molecular and cellular and synaptic and dendritic levels than we did before. So I'm very excited about that. And then the last method that's a non-cryogenic is solid preservation. That's the one I mentioned that I was originally interested in, this resin embedding of the brain. What you do there is you fix with aldehydes, then you fix the fats rather than clear them out, which is the other thing you can do. Because if you don't clear them out, they'll oxidize. If you don't clear them out or fix them, they'll oxidize and and the membrane integrity disappears, and then you get all those problems we were mentioning where you don't know if you can infer, right? If you can infer in the future. And so what the people who fix the fats do is they use something called currently osmium tetroxide, which is this nasty chemical that nicely fixes it. It has a bond that saturates all the unsaturated bonds in fatty acids. And then it uses osmium, this very heavy molecule, which is electron dense, and that just sits there. So it oxidizes all the fats, and then that osmium sits there, and you have these beautifully visualizable, on an electron microscope, all the fats now. You can see, and of course you can see everything else with the electron microscope, and now nothing's changing. And it was Robert McIntyre who won the prize, our BPF prizes, who was the first to tell me that if you recycle the osmium, you can do that cheaply as well. He was doing some calculations on that because it's an expensive chemical, but you can actually make it and recycle it. And so if you're willing to do solid preservation on a brain, you're again still in the single-digit thousands in the estimates that I've seen. And that's really nice because you had Emil Candiziora on at least twice in your previous pods, and I actually listened to one episode where he said, I'd love to help other biostasis startups, and if they can do low-cost biostasis in particular, I'm particularly interested in providing them startup help. And low cost for him, as he mentioned, is exactly what what the way Ken and I see it, it's in the single digits of thousands. So it's going to be under $10,000, and that both the solid preservation and the fluid preservation are in that camp. They're in this low-cost camp, which to me is exciting because, that's I would call that a game changer.
So I have to challenge you on this low cost kind of aspect, because I've heard this multiple times, and while I agree, obviously reducing the cost is always a good thing. The aspect that I always kind of think is ignored is the SST aspect.
Yes,
which is hugely expensive.
Standby, stabilization, and transport.
Yeah.
Yes.
And I don't think you can. I've heard other people make this argument. It was like, oh, $5,000 for a brain preservation, and I'm like, yes, until you include SST, which, as far as I'm concerned, unless you have kind of some other ideas about how that could be done cheaper, it is probably at minimum $50,000 in addition to whatever the price of the actual preservation is. And so
I think that's a reasonable number. Yeah, that's right. It's a very big number. Yeah.
Yeah. And so it's not that I disagree with the procedure being cheaper, but I just don't like it being kind of misadvertised as cheaper than it really is. So I would add $50K to anybody's number at minimum, and then go from there.
I'm going to push back on that. You wouldn't do it for people who are on the edge of that right now, doing different forms of dying than what we typically talk about. So in my outline for this talk, I had this, I was hoping to discuss medical aid in dying, MAID, right? Assisted dying, physician-assisted suicide, euthanasia. And the people who do that, there's now the opportunity for assisted dying with preservation, what I call ADP, right? That is now a real opportunity. And the people who do that, they can have negligible standby compared to your 50,000, right? They can go to a hospice. They can transfer to a hospice that's close to any one of these clinics, and maybe some of the clinics are going to offer that. Maybe that's the next level, right? And then they are, their vital signs monitor goes off, and boom, they're in there quickly, and they get a high quality preservation. And 10 countries now offer medical aid in dying, 10 of them, and 3 of them just switched in the last 3 years: Germany, Italy, and Austria. Okay, so they're all caving. They're all caving to medical aid in dying right now. There's 10 U.S. states. Last I looked, in preparation for this podcast, there was only 6 that I knew of, plus the District of Columbia. Now there's 10 U.S. states where you can do this. And so I think what'll happen, I think we're in an adaptive valley. I think SST is very expensive right now because we're at the bottom of this valley. We have to get the scale of the services of the places, and we have to get all of those tools created, maybe some kind of a stasis pod. As you get all those kinds of things happening, so I'm totally agreeing with you. As a futurist, I'm looking a little too far out, and I'm saying, well, what happens when you get the cost down to a level where an average person, middle class income, can start saying, well, I might do this at the end of my life. I don't even need insurance. I can do this at point of need. That's a different thing, and there's a lot less people who have the foresight, if I can go back to that you and I do, right? Okay, I'm going to think ahead. I'm going to put pay my $1 a day to tomorrow or whoever, and I'm going to, when it's ready, I'll be there. But then there's a bunch of other people who are going to want to put that idea off because, unfortunately, death is not a comfortable thing, and we all have maybe a little too much hope, right? That things are going to change last minute.
Yeah, I mean, I think we're in agreement there, and yes, if the if the assisted dying, if this becomes, much more mainstream. You said there's 10 states, and I hope it becomes all the states, and I hope the regulations around that aren't stifling to cryonics or any type of brain preservation. So yeah, I can see that future. I guess where I was pushing back is the now, which is even very amongst those states, I'm going to take a guess that there's some pretty harsh requirements for how you're eligible.
Differs depending on the state. Let me just mention Oregon, because Oregon just last year removed the requirement that you had to be an Oregon resident to do assisted dying in their state. So it was a doctor who challenged them and challenged the state, the constitutionality of that residency requirement, and the state caved. As soon as they had the lawsuit, they caved, and they settled out of court. And since I think it's June of last year, anyone can move to Oregon the last few months, years, whatever of their life, and take advantage of Oregon brain preservation. The Jordan and Sparks, Andy McKenzie, and they also have the $6,000 fluid preservation. Right? They recently just offered that. And what I should mention is I know that Andy is working on a structural brain preservation paper, specifically around fluid preservation, to make the case that I just mentioned to you, that this glutaraldehyde gel does stored just at refrigeration temperature, that there's good evidence and argument that you're still there and nothing's changed. Now, of course, it's still an experiment. We all know that. But as the neuroscience catches up, and we get more and more of that validation, and more people start to see themselves as something, well, I want to preserve myself. And also more and more people believe what we started with, the opening, right? I trust future society enough, I trust my organizations enough that this is a future I want to come back to, and that they will respect my wishes, and I will come back in this way where I'll have the rights that I need, that I have today, right? As more people believe that, I think that concept's going to continue to grow. But to talk about diffusion of innovations for a second, I'm a systems theorist, so I'm going to constantly go to systems, right? And Everett Rogers, right? There's pioneers, early adopters, early majority, late majority, and laggards, right? And the pioneers, that's where cryonics is today. We're not even early adopters, to be honest, in terms of the numbers, right? But we need to figure out how to scale up the early adopters. That's going to happen. There's going to be early adopters, and I think low-cost methods and some of these new techniques, which again, only a few people are going to use assisted dying with preservation, but people don't necessarily know how many people use it in the countries that have had it the longest. So I have a question for you guys and for the listeners. Netherlands is the oldest of all the 10 countries globally that offer medical aid in dying, right? They've had it since 2002. By 10 years later, 2012, what percentage of Netherlanders were using physician-assisted death in dying? Chemicals, and two physicians signing off. We think this person has less than 6 months to live, and here's you can do this yourself, with your family there, right? What percentage of Netherlanders do that, do you think?
I would say more like
naturally dying.
5%.
That's it. That's the highest it's ever been, is 5. It's between 2 and 5%, depending upon the year. But to me, when I heard that number, it just blew me away. I have a slightly different perspective on it than Daniel, because I think most people, they have that hope. Okay, last minute, some new thing could happen. I'm just going to stick around as long as I can, right? And so I thought it would be some fraction of 1%, like 1 out of 100 at most. No, it's been as high as 5 out of 100 people, 1 out of 20 people doing that. That's super courageous, in my opinion. And I want to say something to the listeners. This is a fun thing. There was a movie that came out 2002 called The Barbarian Invasions. I recommend this movie for everybody. It's a dark comedy. And the protagonist has cancer, and he's been kind of a bit of pill. He's been a pill to his family, to his friends, but now he sees his life is measured in months, or most a year ahead. So he has a rapprochement with all of his friends, right? And he talks about these barbarians, the cancer cells that have invaded him, and the hordes taking over, right? Well, he kind of gets that. He gets that. He starts mending some of his past misdeeds with them and making up with them, and then he throws a big party and he tells everybody, I got some, I believe it was heroin or morphine, I forget. I got some hooked up from my friend here, and I'm going to do, because it's legal in my place to do this, so I'm going to do this thing, and I just want to say I love you guys and say goodbye to you all before this thing takes me over and kills my quality of life. I'm going to do it. My quality of life is already gone, basically. So now it's the time for me to do it. And then he does that. And I thought, when I saw that movie, it was almost 20 years ago now when I saw that movie, and I thought, that is such a courageous thing. And I asked myself, well, when will that be something that's everyone knows someone who's done it, who's ended their life that way? I think that's inevitable. I think it will never be the majority, I don't think, but I think it'll be a significant number of people in certain circumstances, particularly with Alzheimer's, right, and other things where they're going to progressive loss of their what they consider their higher self. No, they'll do assisted dying with preservation, and they'll do, I'd love to see a dark comedy. Someone in our camp do a dark comedy with the same theme as the barbarian invasions, but the last third is everybody talking about, well, he's going to do this preservation thing. That's so crazy. Would you do that? Do you want to come back, in that kind of a world? Which family members would say, yes, I want to do it, and the other family members would be arguing, no, I'm not going to do it. It's like, I'd love to see that movie, because that's where we are today, 20 years later. We're now at that stage, was we have these 20 places around the world where you can do this. And I think it's going to be just like, say, gay marriages or women's rights or anything other thing that eventually just kind of, it takes forever, and then it just kind of, there's a step function, it just kind of blows up. I believe a few of these things in our field of biostasis are going to be like that, and the access, having your own choice of how you want to die, that will be one of them. And I know this is a very sensitive topic, and what I should mention is it's easy to get on the wrong side of this topic and help and offend some people and say, all death should be like that. I'm never saying anything like that. I'm saying everyone makes their own choices, and there's going to be certain people who want to make this choice. But I believe that we can move from pioneers to early adopters by various techniques, and this is one of the many things that will do that. People will say, under those circumstances, people should have the right or freedom to go to a preservation clinic and do this. And I totally do believe it should still be less than 6 months to live. I'm very much a majoritarian, perspective on that. Right? I'm not talking about changing any of the consent. In fact, there's got to be more oversight around that, right? Around the consent of doing that.
Would you still agree with that under situations of neurodegeneration of one sort or another, Alzheimer's, where that could take years to run its course, and then by the time you're really 6 months out, there's not much left?
No, that's an excellent point, and you just punctured my argument. Yes, no, I wouldn't agree with that under those circumstances. But I think that might come later. Like the legal informed consent around that might come a little bit later. Just like in the Netherlands, there's 2 points I want to make about the Netherlands. First, they needed 100,000 people in their assisted dying community before they could force the ability to have assisted dying in their homes. So it took them until 2012, 10 years after, before they could have mobile euthanasia clinics, right? But they needed 100, so you could, not just a hospital or a hospice, you could do it in your home. And Also, it was only about 10 years in before they finally came up with rules around informed consent for youth. When can youth end their own lives, right? And at first, the blanket response is, oh, never. And then you look a little more carefully and you say, no, under these circumstances, they should have the ability to do it as well, right? And, we could obviously imagine, like an aggressive cancer in the brain, right? As an example, where it's erasing part of your personality. And, okay, you're not 18. You don't have you don't have the ability to decide for yourself. So you have to be in a framework that has thought that through for you. And again, you get the physicians to sign off on it. And then under those circumstances, yes. So I think these are journeys we're all on, right? We have to have these conversations. We're giving ourselves permission. That's what's so amazing about this podcast, right? Is you guys are getting people to discuss these things, to think about them. I have these 6 hurdles in my head that people have to get to really the value of brain preservation. And one of them is the validation hurdle. Is it going to actually work? They're all things you have to talk through and think about. The second one for me is the societal trust. Can I trust that society is going to be, good enough that I want to come back to it, and that it's valuable for me to come back? Then there's the organizational trust one. Can I trust that this organization is going to be around long enough and stable enough that it'll help me bring me back? Then there's the pattern sufficiency hurdle. All the arguments we can have in our head where, okay, they didn't bring me back. They brought me back in a way where I have pain. It's painful for me to be alive, or they missed some features of me. I don't feel like I'm complete. But I argued earlier that the brain does try and come up with completeness even when you're not fully pattern sufficient. Then there's the copy problem, the copy identity hurdle, right? Is that me coming back, or is that just a copy of me? The uploaders particularly have this problem, but I would argue that it also exists for the reanimators, right? It's just a much milder version of the problem. And then the last one is the multiplicity problem, right? If in the future, the revival technology is going to have the capability to create multiple versions of you. That's very offensive for some people to even think of, right? So can you trust that both, if you only want to have one version of you, society will respect that? And secondly, can you trust that if you want to have multiple versions of you, that you can do that if you want to, and that you can limit them if you want to, and that you can dissociate or reintegrate as you would like to? There's a great science fiction book called The Bug Life Chronicles from the 80s. Phil Jennings was the first to kind of describe this idea that once you can kind of copy and upload yourself, well, you could create multiple versions of you, work on a problem until you come up with a solution. One of them comes up with a solution, and then you reassociate them all because, hey, you want to be a multitasker, but hey, there's a limit, right? There's still me. I want to come back to me, right? And we know you can do that in human brains. That's what dissociative identity disorder and the reintegration that a good psychotherapist does for a person who has these split personalities, right? We know that can happen in a human brain, so why couldn't it happen in a copy? And that's such a weird idea for many people that in my discussion with them, it actually causes them to reject the whole idea of biostasis, right? So these are all hurdles, all of these. And
can I ask you, John,
yeah.
do you consider yourself an uploader?
Yeah, I would bet that uploading is going to be the one that the way most people will come back. That would be my bet, but it's a guesstimate. Yes. I think, but I also could easily see that it could be some hybrid where there's features of biology that the technology can't capture. Maybe it can bring me back in this way where I'm a combination of both, or it's possible that the technology is not pattern sufficient. That substrate is not sufficient to capture the higher features of biology, and So I have to come back partly biological, far or mostly biological, far out into the future. So any of those things that I think could happen, but I would guess that the uploading is going to keep. It's going to be the one that'll happen first and most broadly. And what I need to mention here is Kreider's law. No. Is it Kreider's law? No, that's hard disks. Toomey's law, I think it's called. Kumi's law. Okay. Everyone knows Moore's law. Kumi's law is every 2 years, computers get twice as energy efficient per computation, right? Because of that weird interspace stuff I told you about, right, earlier. The more you can make computation on these smaller scale substrates, the less matter, energy, space, and time you need, less of these physical resources, space, time, and matter, energy, to actually represent a computation. So that's the weirdness of accelerating change, is we can make good arguments today that all of the substrate independent minds, to use that phrase, that will come back, if they can fully come back technologically, will be using very few resources. They're very sustainable in terms of physical resources, right? The trillions of minds that we can imagine in that future aren't going to be some complex, like hard thing to do for the uploading scenario. Now, will that include all the higher features that biology has? I don't think so. I think biology has so much complexity. There's going to be a long time before, and there's going to be a lot of processes that technology needs to borrow from biology before it is, let's call it, computationally and functionally equivalent to biology. And then the last thing I need to say, and this is maybe aspirational thinking, is I think you really shouldn't think of the two as different. You should think of the future of biology and the future of technology as kind of the same, because the technology has to become deeply bio-inspired, and I would argue learn all the lessons that biology has already learned in order to actually be adaptive. And I don't know, that's a big assumption, but
Well, I wanna ground this a little bit in numbers and data. So, I took a survey of cryonicists, people signed up or interested in the subject and sort of adjacent to the subject. So, a pretty broad number of a number of hundreds of people. And one of the questions was, if your brain is destructively scanned and a simulated copy of that scan is run on a very sophisticated computer in the future, is that person you in the ways that you feel matter?
right.
And 48.5% of people said, yes, it is.
Nice. Yeah, it's pretty significant. Yeah.
And the remainder of people said no for various different reasons.
Yeah.
Most popular reasons for saying no were either no because there was a break in the continuity between my present self and that self, a break that was significant enough to make that person not me in some important ways, or no because I don't expect to open my eyes from within that conscious entity in the same way that I expect to do so tomorrow morning in this body.
Right.
So those two alone were the bulk of this agreement. And I think whether maybe you would say that it's not even a real disagreement in some fundamental ways, but I think for a lot of people who are interested in this, they see it as two different camps, and they see that brain preservation, even the name, right? Brain preservation, right? We're preserving the brain. It's not you preservation. It's not preservation of John or Daniel or me. It's preservation of a brain.
Mm-hmm.
And I think people see that as the other camp, the camp that's focused on, the only way that'll be valid if that's more likely to be valid if uploading is a good idea, right?
Yeah.
And actually, this reminds me of a bit of an anecdote here, sort of. But back in, I think it was something like 2016, 2017, something like that. I heard a presentation by Robert McIntyre on his work
Yeah.
over in the Bay Area, and he said it very plainly that the goal for him and this work for him was to preserve. You might hear a cat in the background. So to preserve the memories, because what he found to be most interesting was this idea of having kind of a repository of memories for the future. She's very excited when I'm having these conversations. So having these repositories, so he described it as almost like a museum of memories, right? Like that it was a tragic loss for civilization, for humanity, that all of these memories were going disappearing, right? Disappearing into the nothing, into the ether.
Right.
And all of those experiences, all of those times of joy, that learning, that growth, all of that is gone.
Yeah.
But if only we could preserve brains, we could preserve the memories. And the way I considered, I thought about this was like you have a giant Wikipedia-style database where you can look up John Smart, and there, there's all the memories, and you can look up, when he was, he remember, when the brain was preserved, it's still remembered. When he was 17 and, he had his first kiss, and then when he was 24 and he thought about the future and, all this stuff.
Yeah.
And I think about that and I think, well, I don't care about that. Like, no, sorry, I care about you. I care about your experiences. Yeah. But like, yeah. I don't want I want something different than that. I think is saying for me. That's not what I want. I don't want some database just preserving my memories. I want to preserve whatever me means.
Yes.
And maybe this is why I'm in a different. So since then, I felt like, I don't know, I get what Robert's talking about, and he had all these slides about look how much better ASC is versus vitrification and traditional cryonics. And he showed, the substrate and how damaged it is. And I get all that. But but if the end goal of that approach is this memory preservation, and that's what he's after, or that's what the BPF is after, I don't know that that's what I'm interested in.
Right. No, I very much get that. And I think I am fully in your camp. However, I think you get to your camp through the memory approach. So what we really need to mention here is, for the longest time, the traditional cryonics industry has thought reversible vitrification is going to be the science validation that we're going to get, and we're going to see this massive increase in people interested in our field when we can reversibly vitrify a kidney or some other important organ. I think that's fantastic, and that's one challenge. And 21st Century Medicine and others have been working on that, great people for a long time. When Ken and I started BPF, we said, well, there's another validation strategy we can use, and that is, what does neuroscience say are the critical features of identity? And how do we know that those are being preserved? And when we looked into that more carefully, we realized memory is the most tractable one. That's the first one. That's the first level of significance. And I would argue it actually is the majority of your identity. That's the way I see it as a non-neuroscientist. The majority of your identity is your memory, and it's not static, Max. It's dynamic. Your memory is constantly being reorganized, and it's a process. It has to be called from the static stores into the dynamic workspace that we were talking about. That system that's flowing, that you have to repeat the number or it just disappears. So we have this incredible, and it's incredibly holistic. Memories are not stored in one little location in the network. They're stored in the entire network proper. A long time ago, we used to think Wernicke's and Broca's areas, Wernicke's is for comprehension, Broca's is for speech production, right? Because if you lesion them, then you lose those abilities. And now we know those are actually just network hubs. So a lot of critical processes for speech production go through that special place in your brain for speech processing, and then they fan out to the whole rest of your sensory motor cortex. Does that make sense? It's the whole thing is a network. It's a network. Those are just weak links, if you will, weak links in the system. The system is so dynamic and so holistic. And as you look more closely at just what memory is, you start to realize, damn, that's the most interesting, complex, adaptive system I've ever seen, with the exception of the one I told you about, the fertilized egg that makes that thing, okay, and the whole network of genes that underlie that. That thing is so much the higher parts of me that I care about, then yes, I want consciousness too, on top of that, self-awareness, qualia, rub my fingers together and I have that feeling. But that could just be consciousness could just be the most conservative concept of it, is it's just working memory itself.
Can I?
Consciousness could, sorry, Daniel.
This is a personal thing, and I'm curious. I actually really want to know how you think, because you said memory is the most important thing. And I'll share an experience with you, and perhaps I'm being too narrow with my definition of memory. So if I'm just giving a layman's version of it, and that's why this doesn't make sense. But for example, I had a family member with Alzheimer's disease,
Right.
and I spent a lot of time with her, and her memory at some point it got worse and worse, and then it became non-existent.
Right.
But my experience with feeling like it wasn't her at some point had nothing to do with her memory. When she lost her memory, it was just her, but kind of confused and without good reference point. It was when her personality changed, and when her intuitions changed, and when she went from being nice to not being so nice anymore. These were the things that emotionally, and just because it's my emotion doesn't mean it's correct, but these were the things where I'm like, oh, she's not herself anymore. But when all the memories were gone, I didn't get the sense that I was dealing with a different person. I got the sense she was still there. Now, how the person from her first person perspective would have viewed that, I don't know. But memory was not the one that made me feel like she had disappeared. It was all these other aspects. So I'm curious how you think about that.
Yeah, let me see if I can complexify that for you a little bit in a useful way. So Alzheimer's hits first the hippocampus. So it hits the area that short-term memory that has all the pointers to the long-term memory, and it starts scrambling that whole system. And then that also affects short-term memory, what the person actually pays attention to, and how that activates the whole rest of the network, all those beautiful long-term stores. So my, again, lay understanding of how this works is if you went in and you did Wilder Penfield's work, where you do this slight, this probing of individual neurons in an Alzheimer's brain that's going to be riddled with plaques, huge amounts of that person is still there. They're all there. All the important stuff's all still there, right? It's kind of like lesioning the Broca's or Wernicke's area. You've just taken out that relay, that important thing that stores the last 2 days of experience. You've scrambled that all, and now the person's all dysregulated. And of course, if they get enough of a plaque load in their brain, then they're going to die. But if you remember, if you may not know this, but the famous nun study where they did all these autopsies on nuns, and their brains were just riddled with these plaques in the cortex, and you couldn't tell. The other nuns couldn't tell that they had all the plaques, even though they had advanced Alzheimer's, and that's because they had compensated. They'd kept enough of their short-term memory, and they had deep enough, social connections with others, and they were relearning stuff they were losing in other parts of their brain, and they had these. That's when they came out with the, read all the time, have a strong social life, have a reasonably good health habits, and you can die with Alzheimer's but not of Alzheimer's, right? So I would argue that the brain is really, really good at keeping, the majority of all the long-term experiences, and then there's a separate question of, well, how much is the other pointers? If you completely destroy a person's hippocampus, how much of their pointers are necessary for that person's identity? Well, we have the famous case of HM, right? Henry Meliasen, where he had both of his hippocampi destroyed, and he had all that. He couldn't learn anything new, but he had all of that life experience. And I would argue that's very much like the person who had the spinal cord lock-in syndrome, the brainstem strokes, right? And they grew up training their brain with their body. Now they have no access to their body, but they're still there. And like the book, The Diving Bell and the Butterfly, he wrote that whole book blinking his eyes. That's the only control he had. He's fully there. This, to me, that's a really strong argument that the thing that matters the most, now I'm not saying everything, but the most is the brain. And the same with HM, the thing that matters the most is all of that long-term stuff that we've stored, that whole life, that really determines, hook that back up to a useful hippocampus, even if it's the electronic one like the mice have now, right? And then I would argue that system pops back up and you get all of these wonderful higher features that we care about. I've waved my hands a lot here. As a non-neuroscientist, I get to do that, right? Someone has to go do all the hard work. We're just trading stories at this stage. This is just futures, right? But I think there's enough good evidence that that system is just so good at preserving what matters that we want to keep it there. And to Max's point, Robert was making the Michael Malone point, the guardian of all things, epic story of human memory, right? More memory, better society, priceless memory. But I am with Max actually on this. That I believe that, but I also think what really matters the most are these highest, most complex features of ourselves, and we're just on a journey to figuring out where they are. And I think the most conservative, I don't know if it's the most conservative, the simplest assumption is it's just working memory. Consciousness is just working memory. It's a special type of it. And that's what we want to bring back. And I think if it is as simple as that, then neuroscience will start to converge on that, and we'll probably get to a stage where we'll say, well, the most deeply biologically inspired computers, they're going to start having those same features. And then we'll, to the point that I think you were making, Daniel, there'll be more and more of a natural and tight connection between our biology and our technology. And we won't see them as separate. We'll just see them as substrate independent minds, to use the Randall Kuna's phrase, right? I don't know if you've had him on yet in your podcast, but it'd be lovely to. I think Randall Kuna, from Carbon Copies, PhD in neuroscience, working on whole brain emulation. Robert McIntyre would be lovely to have on. There's some people in this field who all see this problem from pretty complementary perspectives right now, and you guys are now allowing us all to have a chat about it, which is fantastic.
I still want to probe a little more of your thoughts on this, John, because you're one of the, I think you're a prominent figure in this space, and you're someone who thinks about things a little bit differently than some other cryonicists in this space. I think myself included. I think Daniel's actually closer to you on this, and I'm a little further away from this. But if just to understand how you think about this, if we were to do some kind of non-destructive scan, non-invasive, non-destructive, if we somehow could determine the position and the spin of every subatomic particle, etc., makes up your brain. And we can do this, while you're sleeping tonight. Go ahead and do that.
Yeah.
And then we have some super incredible computer, quantum, etc. One of these like powered by a Dyson sphere, whatever. Incredibly strong. And we can actually simulate the the entirety, or I guess, of everything that's happening with all those particles in the software environment, in the computational environment, and essentially run the John Smart program.
Mm-hmm.
Okay, so then let's say we turn it on at the same moment as you're naturally waking up right now in your biological body
Yeah.
in the next morning. Do you expect do you expect that you're going to be kind of looking out of the perspective of that entity's eyes? Let's say we put that John Smart in some kind of further simulated world, etc. Do you expect to be looking out of the quote-unquote eyes of that John Smart, or the one that you're waking up in the bed of, or
Yeah.
both?
Well, this is a this is kind of a
Either way.
softball question. For me, this is kind of a softball question because
Please.
it's both. It's both. Yeah, it's the multiplicity hurdle. It was the last hurdle that we just discussed, right? It's kind of one of the weirdest for people to even contemplate, but it's just natural. It's the natural extension of the copy identity hurdle. Once you can make a copy, you can make multiple copies, and or keep the original around and make a copy. And if it's pattern sufficient, then it's just another you. And then I think we would both look at each other and immediately realize that we're going to start diverging into two separate yous, two unique identities. And in my perspective, I would want to know the circumstances under which it's legal to do that, and my capacity for reintegration if I wanted to. I think it's pretty easy to argue that we'll all still want the capacity to end our lives at any point if we don't like the way things are, or put ourselves on pause. But we're also going to want these other interesting capabilities, which seem a little bit, they're just so different. They're a little bit, to use the term, uncanny valley, right? You get this. That just doesn't feel like my identity anymore when I can make multiple versions of myself. But I think you can find many. You can just go right to multiple personality disorder in humans. You can go right to the ability to argue with yourself, right? And this is why I really like this idea that we never get rid of death, we just tame death, right? The hashtag I would love to see for our field is live on. That's the hashtag I like to see. Is we're all putting this on our profiles and stuff over the next 10 years. Live on, right? Hashtag live on, because it's another one though that's been around is death of death. My good friend Jose Cordero, who I'd love you to have him on too, right? He's another fantastic, good friend of mine for 20 years. Yeah, he wrote this wonderful book, The Death of Death, this new book. And I told him, when he was writing, I was like, I just don't like that title. I love the idea, but life doesn't get rid of death. Life just tames death. Life just, when you argue with yourself, you're creating two separate copies, two separate neural nets, representing a lot of the same information, but each has a slightly different perspective on it. And you're going to argue with yourself until the data comes in. And then you know what's going to happen to the one that loses? You're going to do what's called long-term suppression on it, which means you're going to change all the weighting so you no longer have access to that information. You're essentially killing it.
Resolve the cognitive dissonance. Yeah.
Yeah, you're essentially killing it. Your brain is constantly killing off things that are less adaptive and growing and learning with new things. So death and life are still fundamental, which is why this phrase indefinite lifespan is so much better than immortality, right? Immortality is good as a start, but it's an indefinite ability to finally control growth and learning and death in a way that is the most adaptive. And that's what life's constantly done, right? Life is the sorry.
I don't want to get us away from this philosophical point too far, because
what's the point?
Maybe I'm a little bit dense on this subject. But when you say you're going to be opening your eyes from within both perspectives.
Exactly.
On the one hand, I understand what that means, because I think it's clear that whatever you are is encoded in some fashion by the arrangement of the bits of stuff in your in within this area right now, at least. It's
Yes.
encoded here,
Yeah.
and that can be encoded, and that can be modeled and run in on different substrates. There's no reason to. I don't think it's. I don't think biology is the only way to encode life or even human life.
Yeah.
I think so. So let's get away from that. There's no
And we can also agree we
Neanderthal,
can
no
also
souls.
yep,
Yeah,
we can also agree that that thing is at least two wonderful lenses we can use for understanding it from a complex systems perspective: physics and information.
sure,
So
sure.
that thing is a physical thing, but it's also an informational thing. It's a brain and it's a mind, right? It's a thing that experiences qualia, and it's this set of physical processes. So I don't think that duality. I don't think you can reduce that duality usefully. The two are coexisting simultaneously. So the two physical versions of me are both going to have that informational mind qualia property. They're both going to be real informational entities and real physical entities. And the informational part I like particularly to think about because that's the part that's going to it's going to have preferences. And I think there's going to be a whole bunch of regulation around what kind of copies are allowed, when they're allowed, how much they're allowed, and what freedom there is for reintegration of them. Just like there's all these regulations around violence that we have. What kind of violence, what kind of death do we allow in our societies under what circumstances, right? I think it'll be the same.
But okay, but both of those entities, as we both agree, are informationally identical, or certainly at least were
At that
during
point.
the fork.
At that point.
That forking point.
Yeah.
Physically different, but informationally identical. And okay, so I'm perfectly happy and willing to say both of those entities are going to be now experiencing whatever consciousness is, and we can put
Right.
that on the side, throw it
Yeah.
on the shelf, bracket
Yep.
it, whatever you want to say, because that's a whole can of worms we don't have to get into, right? But like whatever that is,
Yeah.
that's there, and it's there in your case right now, right? And it's going to be there in the case of that entity that's running on this computer. Okay, sure.
Yes, sir.
But I guess what I still don't understand is when you say both, when those entities open their eyes, you are both of those things. I would say
Let me see if I can let me put it another way. Let me put it another way.
Okay.
A certain level of complexity exists in a genetic system. And there's a certain level of mind and consciousness, mind and intentionality in all genetic systems. Okay? So even bacteria, when they have these predictable preferences and predictable sensory motor response, well, it's not sensory motor, I can't use that phrase. They have these predictable biological responses to protect themselves and to seek out food and avoid toxins. A bacteria will bind copper to the inside of the cell wall so it doesn't mess with the machinery, and it has specific systems that have been evolved to do those things, right? So they have intentionality. They have some level of mind, right, of informational complexity as well as their physical complexity. But one of the earliest things that bacteria figured out how to, that molecular biology figured out how to do was to replicate the template. So you can create two genetically identical twins. Why can't you create two genetically identical minds? Technologically identical minds, two functionally identical minds. It's just another level of freedom that life is going to get, right? It's a weird one for us, but I'd say it's no weirder than looking at two identical twins from across the room. That's weird too.
I don't think Max would be arguing that that's not the case, that you can have that they can be identical. I think he'd be arguing that the other one is not him. And so
is that where you're going, Max? Is that the copy is not you?
The way I look at this is a little bit. So the way I look at this is that there's actually two valid perspectives, and they're simultaneously valid.
Okay.
So there's the external perspective, and then there's the internal perspective. So from an external perspective, um, both of those individuals running, for let's say I'm talking about you. So the John, and that's the meat stuff, and the John that's running on this computer.
Yeah.
Both of those people are you, right? I mean, obviously we could talk about how they're different biologically or whatever, but in some fundamental way they are you.
Yeah.
And obviously we could also talk about if we, the transporter thing, where if we made a
Yep.
perfect replica, molecule by molecule, of everything that's going on in your entire body, we could just, I would say from an external point of view, both of those are you. And if somebody said, well, you have to, we're only going to allow one of those to exist, and we're going to kill one, erase one from existence, but you have to choose, Max. And I'd say I'm indifferent to the choice. They're both the same. The fact that, I could be some kind of like originalist, but that's the original John, and he's the special one, and this new one, that's the new one. That one's not as true. But I'm not that, right? And I fully accept that both of those are the same.
Yeah, I would respond to what you just said to say I think it would be subjectively violent to kill either of them.
Oh, for sure. Yeah, no,
Yeah.
I agree.
Yeah. And both of them would not want it to happen. But if it did happen, I would argue that the level of violence is kind of like the level of death, right? It just gets more and more tamed. It's like if you lose the copy of you, it'll be like losing a hard drive and having to go to the backup, right? It's painful, but it's a lot less painful. That to me is what life seems to learn how to do, or want to do at least. It wants to back up the relevant complexity better and better, so it can try these experiments. It can do these forks and try things out, and then learn from the experiments. And so, I don't know if how that relates to your thought experiment, but I'm curious. What?
Well, I think, and I think. Because of the fact that you feel that way, you would, if you could talk from out of this room where you're in this ridiculous experiment, both of you would say, well, this sucks that I'm going to be the one that maybe has to go, but at least the copy is going to be around. You'd both probably agree on that.
Right.
But I guess my thing is that from an external point of view, from my point of view, as far as I'm concerned, I'm indifferent to which one of those two is the real you. They're both the real you from my perspective.
Yeah.
So I fully agree. However, I think there's an internal point of view that is not discussed, where to you, so you, the John Smart that's speaking to me right now, are going to be opening your eyes in a certain place tomorrow. And there's a new entity, a new kind of conscious being that happens to share all of the memories and all of the experiences and all of the personality quirks and all of those things, and is going to call themselves by the same name. All of that stuff will be identical, but it is a new entity. It is a new conscious being, and
so
different from the.
So this is where we have to get into the splitting hairs, and I would argue that we're just going to learn. We're going to learn a new way of understanding and thinking of identity when we get this new freedom. Now, one of the things that convinced me that the copying really is no different is when I went to second undergraduate in molecular biology at UCSD. Never finished the degree. I went on and started a business from that, but almost finished it. And as I did it, I realized, well, that's what nature is, just copying and varying all the time. I'm constantly copying myself. I'm a stable pattern that's constantly undergoing entropy and recopying itself. And it can only do it for a certain level until it gets overwhelmed by the entropy, because we're an imperfect error corrector. That's why the longevity problem is such a big problem, and why we need biostasis, right? The average person dies with, I think if they're 80 years old, they have maybe 70% of their brain is full of something called lipofuscin, which is this undigestible cellular trash. And it actually starts interfering with the whole genetic machinery of the system. So it walls it off nicely, but it can't stop the entropy growing, right? So, but how does that system work? It's constantly copying and fixing. As you no, you're all made of new atoms. Every so often, you're all washing through, except for the crystal lens of your eye and a few other non-biological properties or parts of you. Everything else is copying and replacing itself. So copying is fundamental to the system. It's trying to do high fidelity. It's failing over time. And so you want more fidelity in your copy, and you want more capabilities in your copies. And I do not think the problem you mentioned is different from the transporter problem meaningfully. So Ken has a wonderful book, or wonderful article, which I'll put in the show notes, on that's imagining kind of a transporter network like a couple centuries from now, where people are kind of transporting through the solar system. And he's basically, his argument is there's two classes of people. There's people who are going to say, sure, go ahead, molecularly disassemble me, reassemble me from new atoms over on Mars a few minutes later. And there's people who will say, no, I don't want that. I don't. Even though we have the no cloning identity rights thing all worked out with the future UN, and there's only going to be one of me, unless I want to, right? There's only going to be one of me. I don't want to do it because that's just going to be a zombie. And my argument, or his argument, which I think is very relevant to you, is both of those perspectives are correct. There's the people who will be saying the copy is not me, and they won't be doing it, and the people who will be saying the copy is me, or the copies are me, and they will be doing it. And both of those are going to be self-consistent, and both people are going to be happy with their choices, and we need to respect both of those choices. But one of them is going to be more adaptive than the other. That's the really interesting part. One of those choices is going to be able to do more experimentation, more learning, more growing. This is the Greg Egan's thing in I forget the science fiction, but it was the Jewel Heads, his Jewel Head series, where there's this little nanotechnological thing the size of a large jewel sitting in your spinal cord, and it backs up your brain the whole time, and people are dying, and then they're going into the wreckage of that person dying biologically. They're pulling them out of the crashed plane or whatever, and then they're reinstantiating that person from the jewel, right? And people who live like that are going to be just generally less fearful and more exploratory, right? Now, I'm not saying that's necessarily a better way to live. I'm just saying it's a more adaptive way to live. If nature is constantly creating greater complexity and adaptiveness, the people who see themselves already as copies, and who just see I have more capacity for copying under more adaptive environments, that's just the nature of the future. If I can use that really maddening phrase, the nature of the future, right? It's like that's where the universe is taking us. We don't necessarily all want to go there.
John will be holding a lecture on Mars, and I will be transporting there, and you'll be like, no, I'm staying here.
Exactly.
And you won't get the information. And
well, he'll get it. He'll get it. He'll get it later. That's all. Yeah, he'll get it.
You misunderstand. I would be perfectly happy with the transporter doing that and sending a max there. But I want it to be a non-destructive, non-invasive scan, and then I'm perfectly happy with it. Just you can have 100.
Okay, then you're totally back to my way of thinking, which is then I just want to make sure the reintegration capability is there. I want to be able to compare the two and see the neural correlates of identity that are slightly different, and then decide which of those I want to reintegrate, and then reintegrate.
I think that does sound intriguing if it could work. I think my primary concern just comes back to this sort of point of view that I think I have a point of view, and when somebody says, look, we're going to make 100 copies of you and they're all going to have your point of view simultaneously, I think that starts to sound, I don't know how to bite that bullet. That doesn't make sense to say I'm actually having 100 simultaneous points of view.
Yeah.
I think even when
I
you
think
say
what we need to add to this to constrain it is some form of evolutionary dynamics. We have to say that these systems are going to be in competition and cooperation with other systems at that time, and they're going to create a set of collective ethics, a set of network ethics that everybody has to follow. That's the critical part that, to me, was so helpful for me, so clarifying for me in trying to understand this mystery of accelerating change. A priori, you would not think humans could continue to accelerate in their complexity. You expect some kind of great filter, the system's going to fall apart at some point. But you look at the history so far, with all those catastrophes, and there is some kind of a network adaptiveness that keeps the system constrained. So there's never too much top-down, there's never too much bottom-up, and a set of ethics emerge on what is allowable, right? What is allowable? That's the beauty. Science is mute. Science is mute on universal ethics right now. We don't have it. We don't have one. But I think we're going to come up with one. We're going to come up with a better understanding of what is adaptive for groups, for healthy ecosystems. That's where network science and complexity science have to go. And I, for one, am hoping that if myself and my family come back in the future, we'll know that stuff a lot better, and I'll find my spot, my place to fit in. We haven't talked about the value yet of preservation, right? The story around preservation. But one of the big values, I think, is going to be, how do you know that you're going to be useful in a world where you can today run a personal AI that's going to start capturing your life and then maybe speak to your kids when you die? Why do you need to come back? How do you know you yourself is going to be useful? I think you know that when you start to see just how much more complex and unique you are, your whole self, than these primitive technological systems which are capturing just pieces of yourself, and they're these little, let's call them really dirty copies of you, right? They're not the real you. And to also realize that in that future world, number one, you can continue to be just like you are today. That's often forgotten, right? I want to see a world where Amish people, this is Spider Robinson's idea of Earth Park, where Amish people are coming back in a world of advanced AI, and they're continuing their communities, living in the ways that they always have lived, the way they like living, with some additions. As you may know, Amish people use cell phones on their own terms today, right? They're not allowed to use them with other people in a way that, there's no screen staring in those communities, right? It's like, okay, I want to see a world where people can come back and just be like they are, biologicals in their particular biological environment, and a world where people come back and do all this interesting, substrate independent stuff. And both of those systems survive with each other in coexistence. How do I know that's possible? Because that's the whole history of life today. Just increasing diversity and increasing numbers of adaptive niches. And at the same time, at the leading edge, increasing depth of complexity and consciousness. That's Teilhard de Chardin's insight, right? He called it a law of complexity consciousness at the leading edge. So massive new diversity and this increasing, let's call it the wonderfulness, right, at the leading edge. And so I think that's the kind of world we want. We already recognize we want that in our culture. We want diversity, equity, inclusion. We want more empathy, more ethics. And so,
I would add, John, that the reason I don't worry too much about this question of whether we will be useful in such a world is because we already keep around a lot of things that are not actually all that useful in our world. So
that's another great way of putting it, isn't it? Yeah.
Yeah.
Or they're maybe they're very locally useful, right? That's why we haven't got to this yet, but the social psychologists tell us women are way more relationship oriented than men, just built that way. Men are more willing to just kind of sacrifice themselves to crazy things, right? And maybe in some show of, hey, look at me, maybe you want to mate with me, right? And they're both super useful. That sexual dimorphism, right, and values dimorphism is super useful. But so what that tells us is, if you're not offering biostasis to family and friends, if you're not focusing on the group that's coming back and helping them in their revival story realize, hey, I can stay exactly like I am with my family and friends, or no, I'm going to change, and I'm going to decide how much I want to change. Just like you decide in your own brain, what parts of the way you think do you want to kill off now because it's now anachronistic, and what parts do you want to keep, right? When you start to see the incredible wisdom of pieces of you and the incredible foolishness of other pieces of you and the ability to control, how much I change, then you start bringing on the people who realize, yes, I'm going to stay in a network that I care about in that future, and I'm going to be valuable to that network at least, and then you can have leaps like I do around how valuable I'll be to the whole network. The leap that I make is no intelligence is ever fully capable of capturing its past and its unique diversity of its past. So there will be problems and questions I can work on, even if it's 200 years, 300 years in the future before I come back. There'll be problems and questions I can work on with my unique capabilities that will be useful. I'll add, so my diversity will be useful. There'll be things that still haven't been solved, new problems that have been created. I'll find a place to fit in. And so I have that social faith, if you will, leap of faith, but then it's a smaller leap of faith to know, no, my kids come back, my dog comes back, all the things that I care about now come back. I'm going to be useful to that network too. That's the local network that I understand. And so I think there's levels at which we make those, let's call them stories, right, that we tell ourselves. And we convince ourselves. We get over that hurdle. That's the social trust hurdle we were talking about, right? Societal trust or societal value is the other way of looking at it, right? Is that we have to jump over those hurdles, and I think we all need to we have to practice jumping those hurdles, right? By telling these stories, because there's, every single one of them is certain people are gonna drop out and say, no, I don't want to do that, and then we lose diversity. We lose the diversity that we want. I'd like to end, if you will. I know we're over, but I'd like to end on one concept. So Andy McKenzie at Oregon Brain Preservation gave me this concept, and I think it's so brilliant. If we want to really accelerate people taking biostasis seriously, there's lots of strategies we could take. The one that I like the most is what he calls preservation subsidization. Now imagine that somebody puts up $1 million for 1,000 people who might want to preserve themselves, and they make this available. They make $6,000 or something on that order, something less than $10,000, available to each individual who wants this money, and it has to go to has to be associated with one of the existing services companies, and a contract is signed. And so Oregon Brain Preservation currently has fluid brain preservation for $6,000 available in Oregon, right? So that's 1,000 people, that's 600,000. Now let's add another 400,000 for overhead and marketing. And now some philanthropist decides to put $1 million up for 1,000 people to get free brain preservation or free biostasis. We should call it the most inclusive term, free biostasis, right? By any method. Okay, it could be whole body, it could be brain only, it could be neuro, it could be any of the methods we were discussing. What does that do? If they make it available inclusively and they focus on, so it's representative, those 1,000 spaces are representative of different ethnic groups, different religious groups, and they make the marketing focus on the currently underserved groups. So they do an extra effort to bring in women, to bring in, let's say, all the Christian cryonicists, because you and I all know people who say, sure, that's great, God's going to take me whenever. In the meantime, the way I'm reading the Bible, I should do my best to preserve, life, and I'm going to, and this Jewish tradition has this as well. I'm going to preserve life as long as I can, and then if I finally do die, then I'm going to go to see my Maker. But in the meantime, I'm just going to preserve what I can, right? So find all the people, let's say several hundred people in different major religious groups of Muslims, right? And they all take this free $6,000. Well, if they are signing up for, let's say, Tomorrow Biostasis or Alcor, that's going to cover about 15 years worth of their dues on a subscription contract, right? On life insurance, it's going to cover the enrollment. If they're signing up for something like a fluid or a solid, eventually in the future, solid preservation under $10,000, then that's going to cover the whole thing, let's say. So what have you just done? You've just changed the whole perspective that this is some elitist or oddball thing to, hey, this is available. This has been made available to anyone, and we're going out of the way to focus on making sure that anyone who might want it gets it. And we're training up all the existing services companies with understanding better preservation methods and improving experience, lowering costs just a little bit because they're still early in the adoption cycle. But then what happens next? Some philanthropist might then raise money specifically for some specific group and do the same thing. And then you might start seeing specific networks emerging for covering, people with particular philosophical, ethnic, religious persuasions. Suddenly you get something that looks, from my way of thinking, like life itself. It's this diverse network of choices and services. And how did that happen? It happened because some crazy person gave $1 million to just bootstrap everyone's awareness, and they could stop doing the DABDA stages. You know what those are? Denial, anger, bargaining, depression. There's one that comes before before denial, though. It's ignoring. So it's actually IDABDA. First, everyone tries to ignore the thing that's the big change, and then when they're forced to, they deny that it's real. If you gave 1,000, if some philanthropist gave 1,000 of these free suspension tickets to the first 1,000 people who sign up, and they allowed them to sign up X number of family members right off the bat too. Maybe each person gets 3 family members. They get it for free. So you get this. Finally, you're going to get the people. Start with all the Redditors and everybody who really already like, oh yes, I already think this way. And then it's going to suddenly move out of pioneering into early adopter. That to me is one of many ideas that have been discussed that I think, but in particularly, I think could be a really exciting thing for our field. So any philanthropists out there, I went into all of that detail because I think this is a great opportunity for you to step up and talk to Andy at Oregon Cryo or Oregon Brain Preservation or any of these other wonderful services companies and see if you can get something going like this that really helps the whole field jump to the next level.
I think that would be definitely a great idea, and it has the benefit of being able to be done kind of bottom up in a sort of piecemeal way, rather than the more traditional approach, which would say something like, just convince Taylor Swift, and then everything follows from there. It's like, well, yeah, sure, but that's a really big lift relative to the slower way.
I think it's very similar to kind of conciliant with your idea of the go freeze me, or what I would call the go preserve me, or the database of the biostasis database you were talking about, where people put up a 3-minute video on why they chose to do it, And I think that database should include anybody who's advocate, not necessarily signed up. That's just because I'm looking more long term, and I think it's a small step for a person to say that, but it's a big thing for a person to watch a 3-minute video on someone who's flipped their way they think about it, and to hear why they flipped, right? It's all around these complex questions of, wow, there's so many hurdles we have to jump through in our head, but hey, I've jumped through enough of them myself that, yeah, I want to do this for me and my family.
So, John, I know we've covered a lot of ground, and this has been like a, going in every direction podcast.
Yes, sir.
And we're coming to a close, but we like to end these podcasts on a small segment we call overrated or underrated. And we just have a few of these for you today, but it's very simple. Do you think this, as a concept or as a practice or whatever, this thing that I'm going to say, is it overrated, underrated, or appropriately rated within our communities, right? Okay. Within these groups. So the first one is nuclear power.
Nuclear power, that's interesting. Well, I would say in the short term it's overrated, in the long term it's underrated. So today I think it's a little too dangerous for us to be scaling it compared to all the other renewable technologies, which are rapidly improving and rapidly lowering their costs. But in the long term, I think nuclear power is going to have a lot of benefits. It's incredibly sustainable, but I think we're going to need much more complex regulatory and AI and other systems running it. My biggest reason, I actually wrote a Medium post why we should delay nuclear power. And my argument there is there's a lot of really scary capabilities to kind of accelerate weapons proliferation today that could actually threaten cities over the next several decades. If we had a lot more people trained in nuclear physics and nuclear chemistry. And so I would rather, if we don't have to do that for climate change, I would rather see us scaling all these other technologies and keep it at its current limited base, where we use it for subs, we use it for research, we use it for critical technologies, and then we keep it as a backup, right, in our electric grids and things. We keep a few of them around, and we limit and we increase oversight on nuclear fuel processing and uranium mining and these new technologies that are kind of dangerous in the short term, but in the long run, I think I'm optimistic that we will gain the wisdom to handle it.
But I thought these newer sort of contained systems, like these micro nuclear power, like they can fit in a pallet on the back of a truck and then get buried deep underground.
They're beautiful. They're beautiful. In my article, I
thought they were hardened against kind of nuclear weapons proliferation.
They are. In my article on why we must delay nuclear power, I acknowledge all those advantages. The one thing we're missing, I think, from this is what's called societal unlearning. We've been smart enough to unlearn massive numbers of people understanding nuclear chemistry and nuclear technology, because it has so many of these downsides in its current first generation, and because we're not smart enough to upgrade all of our old systems to the new ones. So everybody's kind of been the cost of it has been going up, but the biggest problem that's not discussed is the weapons proliferation capability. All these new technologies for cheaply refining uranium and creating bombs that are clandestine, they're all accelerating at the moment. And the thing that's going to stop that from happening is these maturations of technological and political immune systems. And that's not a short-term thing. That's a century-long project. In the meantime, if you want to prevent the possibility of people using a technology like laser isotope separation in their basement to make nuclear weapons and then do all kinds of fanatical things with it, the best way you prevent that is you limit the number of people who know how to build these things and scale the technologies, because they're what's called dual use. The person who learns the ability to make these beautiful fourth generation pebble bed reactors now has the ability to dual use and sell that technology, open source it. Unfortunately, that's just the nature of technology, right? So we put speed bumps in front of the things we don't like, and we accelerate the things we do like, and that's the huge moral choice that we have. So you started with the really tough one, I think. That's a tough one to defend, but I'm still going to try and defend that we slow roll all nuclear scaling. We keep it at its current level. And we focus on everything else. And that's because we recognize, no, I'm not quite confident my society's smart enough to prevent more AQ cons out there, selling and weaponizing the tech, which is what we saw in the 20th century.
Yeah, we figured that would be an interesting one for our audience because it's. I think you're in the minority position.
I am.
On that,
I am. Yes.
A good one to kick it off with.
Thank you.
Number 2, overrated or underrated, radical life extension.
Very underrated in the long term, overrated in the short term. I just don't think before you get AGI, if it comes, late in the century, as I think it will, because it has had these bio-inspired capabilities built into it, which we're nowhere near building yet, right? You can't get the so-called longevity escape velocity. That is unfortunately not possible until you get the AGI that can deeply simulate our biology and redesign things, because our brains are differentiated tissue, right? And we have no idea at the molecular scale how to fix differentiated tissue. We can keep endlessly replicating the undifferentiated tissues like Hydra or cancer. You can take a cancer cell from a person's body and it's immortal. That's what a HeLa cell is. But that's because it's de-differentiated. All the things that are differentiated, that store all these wonderful complex things, we don't know how to keep those things going forever. That's the thing we were trying to learn. And if that's really tough, we have to recognize how tough it is and get this biostasis lifeboat going.
So it sounds like you're saying working on the radical life extension component today is a little bit like it's like working on the problem of how do you get a man to the moon when you haven't even figured out how to powered flight yet.
You cite that famous example, and I think it's appropriate here. And it's because of the word radical in front of it, unfortunately. I'd totally see 20, 30 years of health span being absolutely achievable. Even in the next decade, we might get a 20-year jump with some cool, unpredictable new thing, right? But it's still going to be Olshansky's curve, where the whole system is falling apart at an accelerating rate at the very end, and that's your ideal, right? You compress frail span into this tiny fraction of things. That's great. You get people living super, healthy. But there's just too many difficult things after 100, right? I mean, Jane Calment was blind for the last 10 years of her life, right? All these systems fail. They fail, and they're all interdependent, and they're negatively synergistic. That's the problem, right? So you get these beautiful ability to extend. Like if we come up with the anti-senescence drugs, oh man, wouldn't it be awesome if people are feeling like they're learning like 40-year-olds when they're 90, and then they start falling apart over 10 years? That starts to change the nature of aging into something that feels more like a person who gets cancer when they're in their 20s. Suddenly you're going to have people getting really angry about dying. So I think regular longevity could do these amazing things for us. But when you add the word radical, that's where we have to think, okay, yeah, eventually. But that's not a problem I think humans are going to easily solve. And so we really need people to see the value of biostasis that as a solution that's already here. We just have to get over those 6 hurdles I talked about mentally to say, yeah, okay, I'm over the hurdles. Count me in.
It's interesting, but both of these you've said you're they're overrated in the short term, but underrated in the long term.
Yeah.
That's,
Can you give me one where I don't respond like that? I know we're way over time. I know, but
I'll try one. So the last one is because something I never hear you mention, but I think it's a lot of people consider when they're doing biostasis, whether it's cryopreservation or anything, they think about long-term wealth preservation as well, and how that complicates the scene.
yeah.
But do you see that that's sort of? I feel like you might say something like that's not really relevant. I mean, especially if you come back and you don't even in some sort of uploaded.
Underrated.
version.
It's underrated.
Okay.
I think it's underrated right off the bat. I think what Alcor has done with his patient care trust is beautiful. They've done a lot of really good work, and that's one of the best things that I really like is that Max Moore had a recent post on it where he was looking at patient care. How is patient care trust? How do the trusts work in all the different services firms? And Alcor compares so favorably at the moment because it's done a lot more of that legal work and thinking. And I really love the idea that people recognize accelerating change. And they recognize that the last 10 years the stock market has had an average of 11% real returns. Inflation adjusted, I think it's 9%. It's unheard of, right? Is that going to continue? Is that real wealth creation going to continue? I would argue it will. This is pre-singularity economics, right? More and more of that wealth is virtual. It's relational. It's network-based. It's informational versus physical, right? So if that continues, and someone gives you $6,000 for free preservation, and they give you an additional 1,000 to put into your patient care trust, but it's patient care / personal wealth, because there's a little clause in there saying, well, if it doesn't take you all the patient care money to revive you, because it won't, because I'll be free by then, I'll be robots doing it. Well, you can have the rest of it for yourself and your family. Well, I can make an easy case that $1,000 of that, if you're coming back, 80, 100 years from now, you're rich, inflation adjusted. Still, you're rich, right? And that's fantastic, because that just gets back to the ethic that we all want, which is saving for the future and being being mindful and responsible for thinking about the future. So I think every culture is going to have a different set of political discussions over how much you're allowed to do that. We don't want to see Elon and these other people taking all their money out of the present and putting it into their future story for themselves. So it'll be very limited, but because of the power of exponential productivity, right? I think even a small amount of that allows you to save for yourself. Yeah, I'm caring for myself in the future and my family in the future, and so I think it's still underrated because we haven't got enough lawyers in there working, and we don't have enough advocacy to make that some version of that emerge. And I also really like this idea of family trusts, right, which I've discussed with Rudy Hoffman, who you've had on, and with Emil Kendiziora. I think it'd be fantastic to have some kind of a trust when you sign up as a family that, yes, certain members of your family aren't going to want to do the preservation when it's there after you die, and they'll take such and such inheritance, and the ones who want to, well, they're incentivized to, I'm going to leave this small amount in for my own preservation, so I can join mom and dad in the doer or the mausoleum or wherever it is, right? I think that's going to be really nice when we get to some kind of a family preservation trust. So we start thinking like all these super elite rich people who are spending way too much of their time trying to figure out how much they can preserve their little dynasty, right? It's way too top down, that view, I think. And we just make it more of a bottom up thing where we say, no, it's something everyone can do with just a little bit of a tweak.
Well, I'm glad we're all pushing to get in that pushing for that world to become a reality.
Yeah.
Well,
thank you. Yeah, thank you guys so much for your time.
Thank you, John.
Yeah, And I hope you keep doing what you're doing, and go ahead and check the show notes for any of the links that we've discussed in this. And
Yep.
yeah,
They're going to be very extensive for this episode, by the way. A lot of stuff to see.
Well, honored to be spending this time with you.
Thank you, John. Thank you for coming.